There's a moment, just before something makes sense, when it feels the most confusing. And the ancient world seems frozen in that moment. Not chaotic, not random, but almost understood. As if everything was built on a logic that still exists, just beyond our reach. You can see the precision. You can feel the intention, but you can't fully decode it. And that's what makes it unsettling. Because these remnants don't feel like mistakes or experiments, they feel like results. Like the final outcome of a system that once worked perfectly, and then vanished, leaving only its surface behind. So maybe the mystery isn't what we're looking at, but what we're missing that would make it all make sense. On the remote windswept island of Lewis in the Outer Hebrides of Scotland, standing against the Atlantic sky for more than 5,000 years, lies one of the most mysterious prehistoric monuments in Europe, the Callanish stones. Long before the pyramids of Giza reached their final form, and centuries before the famous stone circle of Stonehenge began to rise in southern England, the people of this distant island erected a complex arrangement of towering megaliths that continues to challenge archaeologists, astronomers, and engineers today. The site was first systematically documented in the 19th century, when Scottish antiquarians began recording the arrangement of the stones and collecting local traditions surrounding them. Later excavations in 1857, 1914, and most importantly during the 1980 to 1981 archaeological investigations led by Patrick Ashmore, revealed that the monument dates to roughly 3000 to 2900 BCE, placing it firmly in the late Neolithic period. Beneath the central circle, archaeologists discovered the remains of an earlier ritual-chambered tomb, suggesting that the site evolved over centuries into a monumental ceremonial complex. Yet even after more than a century of research, Callanish continues to present a puzzle. How did a prehistoric community with no metal tools, no written language, and no advanced instruments design such a precise and astronomically aligned structure? The monument itself is far more complex than a simple stone circle. At its heart stands a ring of 13 large stones, each surrounding a towering central monolith that rises nearly 4.8 meters, about 16 feet, above the ground. Extending outward from this circle are 4 long rows of stones, forming a distinctive cross-shaped layout stretching across the landscape. In total, roughly 50 standing stones compose the main structure, each carved from Lewisian gneiss, an incredibly ancient and hard rock formation, estimated to be over 3 billion years old. Individual stones weigh between 5 and 7 tons, and some exceed 5 meters in height. For a society without wheeled vehicles or iron tools, transporting and erecting these stones would have required extraordinary effort. Archaeologists believe the stones were quarried several kilometers away and then moved across rough, then boggy terrain using wooden sledges or rollers made from tree trunks. However, no definitive archaeological evidence confirming the exact method has been found. Even modern experimental archaeology suggests that moving such stones would have required large coordinated groups and precise planning, raising questions about the social organization and engineering knowledge of the Neolithic community that built the monument. Yet the most fascinating mystery of Callanish lies not in the stones themselves, but in the remarkably sophisticated astronomical alignment embedded in the structure. Unlike many prehistoric monuments that primarily track the movement of the sun, such as Stonehenge's famous alignment with the summer solstice sunrise, Callanish appears to be oriented toward the far more complex motions of the moon. Researchers studying the site in the 20th century began to notice something extraordinary. When viewed along the main avenue of stones leading into the circle, the surrounding hills and the horizon create a natural frame for the rising and setting moon. This led astronomers such as Alexander Thom a Scottish engineer who studied megalithic sites in the 1960s, to propose that Callanish may have been designed to track a rare astronomical event known as the Major Lunar Standstill. The moon does not follow the same path across the sky every year. Instead, over a cycle of approximately 18.6 years, the moon's rising and setting positions gradually shift to their northernmost and southernmost extremes before returning again. During these rare moments, known as the Major Lunar Standstill, the moon appears to skim dramatically along the horizon, rising or setting at points far beyond its normal range. What makes Callanish astonishing is that its stones appear to be arranged to mark this exact phenomenon. When the lunar standstill occurs, the moon seems to roll along the distant hills before entering the central stone circle, creating a visual effect that some researchers describe as a lunar procession. The alignment is so striking that observers standing within the monument can watch the moon travel along the stone avenue and settle precisely within the center of the circle. This phenomenon only occurs once every 18.6 years, meaning that the builders of Callanish would have needed to observe the moon's movements for many generations to recognize the pattern. Unlike solar cycles, which repeat annually and are relatively easy to track, lunar standstill cycles require extremely long-term observation and precise knowledge of the horizon. For comparison, even sophisticated civilizations such as the Babylonians and Greeks, who recorded astronomical observations in written form thousands of years later, needed careful calculations to fully understand the lunar cycle. How, then, did Neolithic builders in a remote corner of Scotland detect such a complex celestial pattern? Archaeologists have suggested that the builders may have been part of a culture deeply focused on long-term skywatching, passing knowledge orally across generations. Others believe the monument itself may have served as a kind of prehistoric astronomical instrument, allowing observers to track the moon's movement against fixed stone markers. But the precision of the alignments remains remarkable. Studies conducted in the late 20th and early 21st centuries confirmed that several rows of stones point towards specific lunar rising and setting, positions associated with the standstill cycle. The long northern avenue, consisting of 19 stones stretching about 80 meters, appears to guide the viewer's eye toward a distant notch in the hills where the moon would rise during the standstill event. When this occurs, the moon seems to glide across the horizon before aligning with the central monolith, an effect that must have been both visually dramatic and spiritually significant for the ancient people who gathered here. The surrounding landscape adds yet another layer of complexity. The site is positioned within a natural basin of hills that shape the horizon in distinctive ways. Archaeologists believe the builders intentionally selected this location because the contours of the land enhanced the lunar alignment, allowing the moon to interact visually with the stones and the hills beyond. In other words, the monument appears to combine architecture, astronomy, and landscape design into a single integrated system. Excavations also reveal that Callanish was not an isolated monument. Within several kilometers lie multiple related stone settings, known today as Callanish 2, 3, and 4, along with smaller standing stones and burial features scattered across the landscape. These structures may have formed a wider ceremonial complex, suggesting that the island once hosted a vibrant ritual center, where communities gathered for astronomical observations and ceremonies linked to the cycles of the sky. Local folklore preserves echoes of this ancient significance. According to traditional legends from the Isle of Lewis, the stones were once giants who refused to convert to Christianity and were turned into stone as punishment. Another story claims the stones are ancient beings who rise and walk when the moon is high in the sky. While these tales emerged thousands of years after the monument was built, They reflect a long-standing sense that the stones are somehow connected to cosmic forces and ancient rituals. More than 5,000 years after their construction, the Callanish stones still stand against the Atlantic winds, aligned with the moon and marking a rare cycle that appears only once every 18.5 years. Whether the site was a temple, a lunar observatory, or a ceremonial gathering place remains unknown. What is certain is that its builders possessed remarkable knowledge of the sky, knowledge that even modern research has not fully explained. What do you think the Callanish stones truly were? An ancient lunar observatory, a sacred ceremonial centre, or evidence that ancient people understood astronomy far better than we assume? Where are you watching this video from? And what time of day is it for you? Share your location and time in the comments below. Hidden deep within a narrow jungle valley in central Vietnam lies one of Southeast Asia's most perplexing archaeological sites, My Son Sanctuary. Built between approximately the 4th and 13th centuries by the ancient Champa civilization, this sacred complex once contained more than 70 Hindu temples dedicated primarily to the god Shiva. Today, although many structures were damaged during wars and centuries of tropical weathering, the surviving brick towers still stand as silent evidence of an engineering tradition that researchers continue to struggle to fully explain. What makes My Son especially fascinating is not merely its religious significance, but the extraordinary construction technology embedded in its red brick temples, technology that appears surprisingly sophisticated for a civilization that flourished more than 1,000 years ago. Among the many mysteries surrounding the sanctuary, the most debated and scientifically puzzling feature is the unusual method by which the bricks were joined together. Unlike most ancient masonry structures around the world, the bricks at My Son appear to be assembled with almost no visible mortar at all. At first glance, the towers of My Son seem to be built from ordinary rectangular bricks, similar to those used in many ancient structures across Asia. However, closer inspection reveals something highly unusual. The bricks are fitted together with such precision that the joints between them are nearly invisible. In many places, the gap between bricks measures less than a fraction of a millimetre, far tighter than the joints typically found in traditional brick architecture. Even more remarkable is the fact that researchers have struggled to identify any conventional binding material between the bricks. In most ancient buildings, such as Roman brick structures or medieval temples in India, layers of lime mortar or clay mortar clearly separate each brick. At My Son, however, the bricks appear fused together almost as if they were part of a single continuous block. When archaeologists attempted to separate bricks from collapsed towers during restoration efforts, they discovered that breaking the bricks themselves was often easier than separating the joints between them. This observation alone has raised profound questions about how the Champa builders achieved such a level of precision and durability. Scientific studies conducted during restoration projects in the 20th and 21st centuries have attempted to uncover the secret of this technique. One of the earliest systematic investigations occurred during the French archaeological missions of the early 1900s, when researchers from the École Française d'Extrême-Orient first documented the structure of the temples. They noted that the surfaces of the bricks appeared unusually smooth, almost polished, suggesting that the bricks may have been carefully ground before assembly. Later, microscopic analysis revealed that the outer surfaces of the bricks contain extremely fine mineral particles, indicating that they were manufactured using a carefully controlled clay mixture. Modern tests estimate that the bricks were fired at temperatures between approximately 800 and 900 degrees Celsius, comparable to advanced kiln techniques used in many historical civilizations. Yet despite these findings, one key question remains unresolved. how were these bricks bonded together so tightly without visible mortar? Several theories have been proposed to explain this phenomenon, but none have been universally accepted. One hypothesis suggests that the Champa builders constructed the towers first and then fired the entire structure in place, effectively turning the whole building into a giant kiln-fired ceramic structure. If true, this would mean that the heat caused the bricks to partially fuse together, eliminating the need for mortar. However, many engineers argue that heating a multi-story tower evenly to such high temperatures without causing structural collapse would have been extremely difficult, especially with ancient technology. Another theory proposes that a natural organic resin derived from tropical plants may have been used as a binding agent. Some chemical analyses have detected traces of plant-based compounds on the surfaces of certain bricks, leading researchers to speculate that the Champa civilization may have used a sophisticated adhesive mixture made from tree resins, oils, or sap. Yet attempts to recreate such mixtures in laboratory experiments have so far failed to replicate the exact bonding strength observed in the original structures. The mystery becomes even more intriguing when my son is compared with other ancient architectural achievements around the world. For example, the massive stone blocks of Machu Picchu are famously fitted together with extraordinary precision, but those structures rely on carefully carved stone rather than brick. In ancient Rome, brick structures were widespread, yet they always depended on thick layers of lime mortar for stability. Even in the monumental temples of Angkor, sandstone blocks were often joined with visible joints or metal clamps. My son stands apart because it combines the flexibility of brick construction with a level of precision more commonly associated with finely cut stone masonry. This unusual combination suggests that the Champa builders possessed a highly specialized construction technique that has not been fully preserved in historical records. Archaeological excavations have also revealed that the bricks themselves were manufactured with unusual characteristics. Compared to modern industrial bricks, the bricks at my son are noticeably lighter and more porous. This porosity may have helped regulate moisture within the structure, preventing cracks in the humid tropical climate of central Vietnam. Researchers studying samples from fallen towers have observed that the bricks contain microscopic air pockets that improve thermal stability and reduce stress during temperature changes. In addition, the outer surfaces of many bricks appear to have been treated with a protective layer that gives them their distinctive reddish sheen. Some scientists believe that this coating may have been applied after construction, possibly using a plant-based oil or resin that sealed the joints and protected the bricks from erosion. Another fascinating aspect of the construction process is the order in which decorative carvings were created. Unlike many ancient monuments where decorations were carved into individual stones before assembly, many of the sculptural details at my son appear to have been carved directly into the walls after the towers were completed. This would have required artisans to work on perfectly aligned brick surfaces without damaging the delicate structural joints between them. Why, the carvings depict mythological figures from Hindu cosmology, including representations of Shiva, sacred animals, and celestial dancers. The precision of these carvings suggests that the craftsmen possess specialized metal tools capable of shaping fired brick without causing fractures. Despite decades of research, the original building techniques used by the Champa civilization remain only partially understood. Modern restoration teams working to preserve my son have repeatedly attempted to recreate the ancient construction methods, yet reproducing the seamless brick joints has proven extremely difficult. Even when modern bricks are carefully manufactured and assembled using contemporary adhesives, the results rarely achieve the same level of durability or visual integration seen in the original structures. This persistent gap between ancient craftsmanship and modern reconstruction highlights just how advanced the Champa builders may have been. what do you think is the real secret behind the perfectly fitted bricks without mortar at my son's sanctuary? Could it be a lost ancient adhesive, a unique firing technique, or a construction technology that we still don't fully understand? Share your thoughts in the comments below. Hidden in the arid plains of Balochistan, in what is now Pakistan, the ancient site of Mehrgarh stands as one of the earliest known centres of human civilization. Dating back to around 7,000 years before the Common Era, this settlement predates the great cities of the Indus Valley civilization by several millennia and offers a rare glimpse into the technological abilities of some of the earliest farming communities on Earth. Discovered in 1974 by a French archaeological mission led by Jean-François Jarige, Mehrgarh immediately drew global attention because it revealed a surprisingly complex society existing at a time when many other regions of the world were still dominated by small nomadic hunter-gatherer groups. Over decades of excavation carried out by teams from the French archaeological mission to Pakistan and the Department of Archaeology of Pakistan, researchers uncovered layers of occupation stretching across several thousand years. These layers contain evidence of early agriculture, organized architecture, sophisticated pottery production, and even primitive medical practices. Yet among all these discoveries, one particular technological achievement continues to puzzle researchers and provoke intense debate: the astonishingly precise stone bead manufacturing techniques practiced by the inhabitants of Mehrgarh. To understand why this discovery is so extraordinary, it is important to consider the broader technological context of the time. Around 7,000 years before the Common Era, most Neolithic communities produced simple ornaments made from bone, shell, or roughly shaped stones. Drilling through hard mineral materials was extremely difficult because the available tools were typically made of stone or early copper. However, excavations at Mehrgarh revealed thousands of beads crafted from semi-precious stones such as lapis lazuli, turquoise, carnelian, and agate, many of which display drilling precision that seems almost incompatible with the technological limitations of the period. Some beads measure only a few millimeters in diameter, yet contain perfectly centered holes that run through their entire length. Even more remarkable are the long, cylindrical beads made from carnelian, some reaching several centimeters in length while maintaining narrow, straight perforations from one end to the other. Look, when archaeologists first examined these artifacts in the 1970s, many initially believed they might belong to later historical periods, but stratigraphic analysis confirmed that the beads originated from the earliest phases of the settlement. Detailed microscopic studies conducted in laboratories in France and Pakistan later revealed that the holes inside many Mehrgarh beads were created using a rotational drilling technique, likely involving stone drill bits made of flint or chert. Experimental archaeology has attempted to reproduce these methods using replica tools. Researchers found that drilling a hole through a small carnelian bead using a simple stone drill could take several hours of continuous rotation, requiring careful control of pressure and alignment to prevent cracking the stone. Despite these challenges, the craftsmen of Mehrgarh produced beads with astonishing uniformity and consistency. In some cases, the inner walls of the drilled holes show microscopic spiral grooves, indicating a controlled, rotating motion similar to that used in modern mechanical drilling. This raises an intriguing question. How did Neolithic artisans achieve such stability and precision without advanced equipment? One hypothesis suggests that the people of Mehrgarh may have developed an early form of bow drill, a tool that uses a string wrapped around a drill shaft and moved back and forth with a bow to produce rapid rotational motion. Bow drills are known from later ancient cultures, including those of Egypt and Mesopotamia, but direct physical evidence of such tools from Mehrgarh is extremely limited. Nevertheless, the pattern of drilling marks on many beads strongly supports the idea that a mechanical rotation device was used rather than simple hand drilling. If this interpretation is correct, it would imply that the inhabitants of Mehrgarh had already developed sophisticated mechanical tools thousands of years earlier than previously assumed. The scale of bead production at Mehrgarh is also remarkable. Excavations across different occupational layers revealed large quantities of unfinished beads, broken drill bits, and stone fragments, suggesting that bead manufacturing may have been a specialized craft industry within the settlement. Some researchers estimate that thousands of beads could have been produced over several generations. The presence of lapis lazuli is particularly interesting because the nearest major source of this deep blue mineral lies in the Badakhshan region of modern Afghanistan, hundreds of kilometers away. This indicates that the people of Mehrgarh were not only skilled craftsmen, but were also connected to early long-distance trade networks that transported valuable raw materials across vast regions of Central and South Asia. When compared with bead-making traditions in other ancient civilizations, the sophistication of Mehrgarh becomes even more striking. In many early Neolithic sites in Europe and the Near East, beads were often irregularly shaped and drilled from only one side, resulting in off-center perforations. By contrast, numerous beads from Mehrgarh exhibit bidirectional drilling, where craftsmen drilled from both ends to meet precisely in the center. Achieving this level of alignment requires remarkable spatial awareness and careful control of drilling angles. Even with modern tools, drilling a narrow hole through a fragile semi-precious stone without breaking it can be challenging. Yet the artisans of Mehrgarh appear to have mastered this technique more than 9,000 years ago. The mystery deepens when researchers consider the broader technological implications of this craft. Producing finely drilled beads requires not only the ability to rotate a drill rapidly, but also knowledge of abrasive materials such as fine sand that could accelerate the cutting process. Some archaeologists propose that quartz sand or crushed stone powder may have been used as an abrasive lubricant between the drill tip and the bead surface. If so, this suggests that Mehrgarh craftsmen possessed an advanced understanding of material science long before the formal development of metallurgy and engineering. Excavations in the early 2010s also uncovered workshops within the settlement, where bead production likely took place. These areas contained clusters of stone debris, drill fragments, and partially finished ornaments, providing strong evidence that bead manufacturing was an organized activity rather than a casual craft practiced occasionally by individuals. The existence of such specialized production zones hints at a level of economic organization and social complexity that challenges traditional views of early Neolithic communities. Despite decades of research, many aspects of Mehrgarh's bead-making technology remain unresolved. No complete drilling apparatus has ever been discovered, leaving scientists to reconstruct the tools based only on microscopic traces left on the beads themselves. Furthermore, the sheer consistency of the drilling suggests that craftsmen were highly trained specialists, possibly passing down their knowledge through generations. This raises fascinating questions about how technical skills were taught and preserved in prehistoric societies that had no written language. The stone beads of Mehrgarh are more than simple ornaments. They reveal a surprisingly advanced technological tradition for the Neolithic era. Combined with evidence of early dentistry, organized architecture, and skilled pottery, these artifacts suggest that the people of Mehrgarh possessed remarkable knowledge of tools and materials. Yet even today, the exact techniques they used to drill such precise holes into hard stones nearly 9,000 years ago remain a mystery. How do you think the ancient people of Mehrgarh were able to drill extremely tiny and precise holes into hard stones nearly 9,000 years ago? Share your thoughts or theories in the comments below. Hidden in the rolling landscape of Ohio lies one of the most astonishing and enigmatic prehistoric engineering projects in North America, the Newark earthworks. constructed roughly between 100 BC and 400 AD by the ancient Hopewell culture. This immense complex once stretched across more than 10 square kilometers, making it one of the largest geometric earthwork systems ever created by prehistoric societies anywhere on Earth. At first glance, the Newark earthworks may appear to be little more than giant mounds of soil arranged in unusual shapes. But when viewed from the air, a far more extraordinary picture emerges. The complex includes massive geometric forms such as the Great Circle earthworks, vast squares, parallel embankments, and perhaps most intriguingly, the famous octagon earthworks. These enormous structures were built entirely by moving earth, more than 200,000 cubic meters of soil, using only simple tools such as wooden digging sticks, stone implements, and baskets. There were no metal tools, no wheeled vehicles, and no written plans. Yet despite these limitations, the precision of the construction rivals that of many later, monumental architectural achievements. The Great Circle alone measures roughly 365 meters in diameter, surrounded by a wall reaching nearly 5 meters high and accompanied by an interior ditch. Meanwhile, the octagon earthworks forms a massive 8-sided enclosure connected to a large circular embankment nearly 300 meters wide, creating a geometric complex whose total span exceeds 550 meters. Modern surveys using aerial photography, satellite imagery, and LiDAR scanning have shown that the sides of the octagon are astonishingly consistent in length, with measurement deviations often less than 30 centimeters, a level of accuracy that is difficult to achieve even with modern surveying tools. Archaeologists who first mapped the structures in the 19th century, including researchers working with the Smithsonian Institution, were already puzzled by the sheer scale and precision of the site. Later excavations and surveys throughout the 20th century confirmed that these structures were not random ceremonial spaces, but carefully planned architectural complexes built with deliberate mathematical relationships. However, the most extraordinary and mysterious aspect of the Newark earthworks does not lie merely in their size or geometry. It lies in their remarkably precise astronomical alignment, particularly with the movements of the moon. In the early 1980s, two researchers, Ray Hively and Robert Horn, conducted detailed measurements of the octagon earthworks. Their findings were astonishing. They discovered that the axes of the octagon and the adjoining circle are aligned with the extreme rising and setting points of the moon during its 18.6-year lunar standstill cycle. This cycle occurs because the moon's orbit slowly shifts relative to Earth's equator, causing the moon to rise and set at slightly different points on the horizon over nearly 2 decades. Tracking this cycle requires observations spanning many generations, because the moon's most extreme positions only repeat every 18.6 years. Yet the Newark earthworks appear to encode these lunar positions with remarkable accuracy. For example, one major axis of the octagon aligns closely with the northernmost moonrise during the major lunar standstill, while another aligns with the southernmost moonrise. When researchers simulated the sky as it would have appeared nearly 2,000 years ago, they found that observers standing at key points within the earthworks would see the moon rising directly along these embankments during the standstill events. The precision of these alignments is so striking that some scholars have described the Newark complex as one of the largest ancient lunar observatories ever constructed. To put this into perspective, the famous Stonehenge in England, often cited as one of the world's most important prehistoric astronomical sites, primarily tracks the movement of the sun, especially the summer solstice sunrise. Newark, by contrast, appears to track the far more complicated and subtle cycle of the moon. Some archaeoastronomers argue that the lunar alignment at Newark may actually be more geometrically precise than the solar alignments at Stonehenge, an astonishing possibility considering the technological limitations of the Hopewell people. The mystery deepens when we consider the observational knowledge required to create such alignments. Identifying the moon's maximum rising and setting points is not something that can be determined from a single year of observation, because the extremes occur only during the major standstill. Observers would need to record lunar movements for at least 2 decades to identify the pattern with certainty. Some scholars suggest that this knowledge must have been passed down through generations of sky watchers who carefully tracked the moon's path across the horizon over many decades. Yet there's no surviving written record, no carved astronomical tables, and no clear instruments associated with these observations. The knowledge was apparently transmitted entirely through oral tradition and ritual practice. Archaeological investigations conducted throughout the 20th and 21st centuries have revealed additional clues about the scale of the effort involved. Excavations have shown that the embankments were constructed in carefully layered stages, with alternating bands of clay, gravel, and soil designed to stabilize the walls. This suggests a sophisticated understanding of structural engineering. Radiocarbon dating from organic material within the earthworks confirms that construction occurred over several centuries, with major phases between 2100 and 1600 years ago. During this time, the Newark complex likely served as a major ceremonial gathering place for communities across the Ohio River Valley. Artifacts discovered in the region, including copper ornaments from the Great Lakes, obsidian from the Rocky Mountains, and marine shells from the Gulf Coast, indicate that the Hopewell culture maintained trade networks spanning thousands of kilometers. Yet despite its monumental scale, Newark was not a permanent city. Archaeologists have found very little evidence of long-term habitation inside the earthwork enclosures. Instead, many researchers believe the site functioned as a ritual landscape, visited periodically for ceremonies that may have coincided with significant astronomical events such as lunar standstills. During these rare celestial alignments, gatherings at Newark may have attracted people from vast distances, transforming the earthworks into a sacred stage where the movements of the cosmos were symbolically connected to the social and spiritual life of the community. Today, the Newark earthworks continues to puzzle archaeologists, astronomers, and historians. How a society without metal tools, written mathematics, or centralized authority managed to build such a precise astronomical complex remains unclear. Yet even more mysterious is how they understood the 18.6-year lunar cycle nearly 2,000 years ago. Despite more than a century of research, the site still suggests that ancient cultures may have possessed far more advanced knowledge of the cosmos than we once believed. How do you think the ancient Hopewell people were able to understand and align their structures with the 18.6-year lunar cycle so precisely, despite having no modern astronomical instruments? Share your thoughts or theories in the comments below. The ancient archaeological site of Ban Chiang Archaeological Site in northeastern Thailand is widely regarded as one of the most intriguing prehistoric cultural centers ever discovered in Southeast Asia. Recognized as a World Heritage Site by UNESCO in 1992, Ban Chiang has captivated archaeologists for decades, not only because of its remarkable age, but also because of the technological mysteries embedded within the artifacts buried beneath its soil. The site first came to global attention in the 1960s after a chance discovery led researchers to conduct systematic excavations beginning in 1967. These excavations revealed layers of human occupation stretching back several millennia, some estimates placing the earlier settlement around 2000 BCE or even earlier. Among the many discoveries uncovered during these digs, such as bronze tools, burial goods, and ornaments, the most iconic and puzzling artifacts remain the site's distinctive pottery vessels, decorated with striking red spiral patterns. These ceramics have become symbolic of Ban Chiang, yet despite decades of study, many aspects of their production remain unexplained. What makes the pottery of Banqiang so extraordinary is not merely its age, but the level of artistic and technical sophistication displayed in its decoration. Many of the vessels feature flowing spiral motifs painted in deep reddish pigments that wrap around the curved surfaces of bowls, jars, and storage containers with remarkable precision. Some pieces measure more than 30 centimeters in height, and yet the painted lines remain smooth and evenly spaced across the entire vessel. The spirals often appear as continuous curves, looping gracefully around the pottery in patterns that seem almost mathematical in their balance. Archaeologists studying these designs have frequently pointed out that producing such uniform curved lines on a rotating three-dimensional surface would have required a steady hand, controlled rotation, and possibly specialized tools or techniques. However, no clear evidence of sophisticated pottery wheels or measuring instruments has been found at the site, which raises questions about how prehistoric artisans achieve such precision. Excavations conducted during major archaeological campaigns in 1974 and again in the early 2000s revealed that these decorated ceramics were not rare ceremonial objects, but were surprisingly common within the settlement and burial contexts. Hundreds of vessels were found placed beside human skeletons in graves, suggesting that pottery played an important cultural or ritual role. In some burials, large decorated pots were placed over the body or arranged around it, possibly serving symbolic purposes related to the afterlife. Radiocarbon dating of organic materials found within the burial layer suggests that many of these ceramics were produced between approximately 1500 BCE and 500 BCE, meaning they were created more than 3,000 years ago. Yet the pigments on many pieces remain clearly visible today, an indication that the colouring method used by the ancient potters was remarkably durable. Researchers believe that the red pigment likely came from iron-rich minerals, such as hematite mixed with clay or other natural binders. During the firing process, which likely occurred in open kilns or pit kilns, temperatures may have reached between 700 and 900 degrees Celsius. Maintaining such temperatures consistently in prehistoric firing environments would have required considerable knowledge of airflow, fuel management, and firing duration. Even more impressive is the fact that the painted spiral patterns were often applied before firing, meaning the artist had to predict how the pigment would react to heat and oxidation. Experimental archaeologists attempting to recreate Banqiang pottery have found that reproducing the same crisp spiral patterns without modern tools can be extremely difficult, especially when working on curved surfaces without mechanical rotation devices. When compared to other ancient ceramic traditions around the world, the pottery of Banqiang occupies a unique position. For instance, Neolithic pottery from regions such as ancient China or Mesopotamia often features geometric shapes, carved decorations, or stamped patterns. While these are impressive in their own right, the free-flowing spiral motifs of Banqiang appear unusually dynamic and artistic for such an early agricultural society. In some ways, the swirling red designs even resemble decorative traditions seen much later in Mediterranean cultures thousands of kilometers away. This similarity has prompted some researchers to speculate about independent artistic development or shared aesthetic principles that appear across distant cultures. Another mystery lies in the apparent standardization of the spiral motifs. Many vessels discovered across different excavation layers display strikingly similar patterns, suggesting that the artisans followed some kind of established visual tradition. Yet there is little evidence of centralized workshops or specialized craft districts within the settlement. Banqiang appears to have been primarily an agricultural community where people cultivated rice and lived in relatively small dwellings. Normally, archaeological evidence suggests that highly refined artistic production emerges in large urban centers or hierarchical societies with dedicated craftsmen. The existence of such sophisticated pottery in what appears to have been a relatively small farming community therefore challenges traditional assumptions about how technological and artistic innovations develop in early human societies. Beyond the pottery itself, Chiang also produced important evidence of early metallurgy in Southeast Asia. Excavations uncovered bronze bracelets, spearheads, and tools that suggest local communities were experimenting with metalworking technologies. Some early studies even propose that bronze production at Chiang may have begun as early as 2000 BCE, potentially making it one of the earliest centers of metallurgy in the region. Later research has debated these dates, with some scholars arguing for slightly later periods. Nevertheless, the coexistence of bronze artifacts and highly decorated ceramics suggests a culture capable of mastering multiple forms of technological craftsmanship simultaneously. Archaeological investigations have continued into the 21st century, with new techniques such as chemical residue analysis, microscopic pigment examination, and advanced radiocarbon calibration providing deeper insight into Chiang's artifacts. Yet even with these modern tools, the precise methods used to create the famous spiral pottery remain partly unresolved. How did ancient artisans maintain such smooth curves without visible guidelines? Did they rotate the vessels on simple turntables, or did they develop entirely different techniques that left little archaeological trace? And perhaps most intriguingly, why did this specific spiral motif become so culturally significant that it appeared repeatedly across centuries of pottery production? Today, the red swirl ceramics of Chiang remain powerful evidence of a prehistoric culture with surprisingly advanced technological creativity. Each vessel reflects a blend of artistic skill, chemical knowledge, and precise firing techniques that still puzzle researchers. Even after more than 3,000 years, the elegant spiral lines remain visible, reminding us that the ancient people of Chiang possessed knowledge that modern science is still trying to fully understand. How do you think the ancient people of Chiang managed to create such perfectly precise spiral patterns on pottery more than 3,000 years ago? Share your thoughts or theories in the comments below. Rising dramatically above the plains of central Mali, the Bandiagara escarpment, Mali stands as one of the most extraordinary archaeological landscapes in Africa. Stretching for roughly 150 kilometers and reaching heights of nearly 500 meters in some sections, this immense sandstone cliff forms a natural wall across the Sahel. Along its face and within its crevices lie hundreds of ancient structures clinging precariously to the rock, many of them constructed centuries ago by cultures whose techniques still puzzle modern researchers. The escarpment has been inhabited for many generations, most notably by the Dogon people, but long before their arrival, another mysterious culture known as the Telem occupied the cliffs. Archaeological surveys conducted throughout the 20th century revealed that the Telem built homes, shrines, burial chambers, and storage structures directly into the vertical rock face. Some of these buildings appear almost impossibly placed, positioned dozens of meters above the ground on narrow ledges where even experienced climbers struggle to stand securely today. Yet among all the enigmas surrounding this site, perhaps the most fascinating is the astonishing durability of the structures themselves, many of which were constructed using materials that should have deteriorated long ago. The architecture of Bandiagara relies heavily on a mixture of mud, clay, and small stones. Materials that, under normal circumstances, would be expected to erode quickly under the intense environmental stresses of the Sahel. The region experiences extreme temperature fluctuations, seasonal monsoon rains, and powerful desert winds carrying abrasive sand. In many parts of the world, buildings made primarily from mud brick collapse within decades unless constantly repaired. However, at Bandiagara, numerous structures believed to be several hundred years old, and possibly more than 1,000 years old, remain remarkably intact. archaeologists studying the site since the 1930s have repeatedly expressed surprise at how well these constructions have endured. During excavations carried out by French archaeologist Marcel Griola and later teams throughout the mid-20th century, researchers documented granaries and cliff dwellings whose outer walls still preserve their original form despite centuries of exposure. Radiocarbon dating of organic material from some structures suggests that certain Tellem constructions may date back as far as the 11th or 12th century. Even after nearly a millennium of environmental stress, the walls remain compact and resistant to erosion. What makes this durability so intriguing is that the building mixture used at Bandiagara appears deceptively simple. Samples collected during modern geological analyses show that the material consists primarily of local clay combined with fine sand, crushed stone fragments, and organic fibers such as straw or plant roots. This mixture resembles traditional earthen building techniques used across Africa and the Middle East, yet the performance of Bandiagara's structures appears unusually resilient. In comparison, many adobe structures in other parts of the world, such as those found in ancient settlements of the American Southwest or North Africa, require constant maintenance and often degrade rapidly when abandoned. By contrast, several abandoned Tellem structures have remained standing for centuries without repair. Some researchers believe that the secret may lie in the precise ratio of clay to mineral particles in the local soil. The sandstone cliffs of the escarpment slowly weather into extremely fine sediment rich in silica and natural binding agents. When mixed with clay and organic fibers, this material may create a form of natural composite that hardens more effectively than ordinary mud brick. Another possible factor contributing to the longevity of these structures is the architectural placement itself. Many buildings are tucked into recessed areas of the cliff face, protected from direct rainfall and strong winds. This positioning effectively shields them from the most destructive environmental forces. Measurements taken during archaeological surveys show that some of the granaries are located between 20 and 40 meters above the base of the cliff, often beneath natural overhangs that act as protective roofs. This ingenious use of the natural landscape dramatically reduces water infiltration and erosion. The builders appear to have carefully selected locations where the rock geometry provided structural protection, suggesting a sophisticated understanding of environmental engineering. Even today, modern conservationists studying earthen architecture consider these cliff structures remarkable examples of passive durability. The design of the buildings themselves also reveals subtle technological knowledge. Many of the small granaries found along the cliffs have cylindrical walls and conical roofs constructed from tightly packed clay, reinforced with wooden supports. The cylindrical shape distributes structural stress evenly, preventing cracks from spreading through the walls. Meanwhile, the steeply sloped roofs allow rainwater to run off quickly, minimizing moisture absorption. In some cases, archaeologists have observed that the outer surfaces of the walls were coated with an additional thin layer of refined clay plaster. This finishing layer may have functioned as a protective sealant, similar to modern stucco coatings. Microscopic examination of plaster fragments recovered during excavations suggests that the mixture may contain plant oils or natural resins, substances that could increase water resistance. However, the exact composition of these coatings remains uncertain, as organic compounds degrade over long periods of time. Excavations carried out in the 1960s and again in the early 2000s uncovered further evidence that the builders possessed an advanced practical knowledge of materials. In several cliff dwellings, archaeologists discovered layers of compacted clay floors reinforced with stone fragments, arranged in a lattice-like pattern. This technique resembles modern stabilization methods used to strengthen earthen floors and foundations. Such findings imply that the builders were not merely stacking mud bricks, but were deliberately engineering composite structures designed to withstand stress and environmental wear. Even more remarkable is the fact that these techniques appear to have been developed without written records or formal architectural documentation. Instead, the knowledge must have been transmitted orally across generations, refined through centuries of experimentation with local materials. The durability of Bandiagara's mudstone architecture becomes even more impressive when compared to other ancient earthen sites. For example, the adobe city of Anshan in Peru, built around the 13th century, has suffered severe erosion despite significant conservation efforts. Similarly, also many ancient mud brick settlements in Mesopotamia have largely dissolved into low mounds after millennia of exposure. Yet at Bandiagara, cliffside structures remain visibly recognizable, with walls and granaries still protruding from the rock face. Some of these constructions appear so well preserved that they seem almost recent, even though archaeological evidence suggests they may predate the arrival of the Dogon people in the region several centuries ago. Ultimately, the Bandiagara escarpment is more than a striking landscape. Its centuries-old mudstone structures show the remarkable ingenuity of ancient builders. Despite modern research, key mysteries remain, such as the exact clay formula, protective coatings, and how materials were moved to such extreme heights. These cliffs still hint that ancient engineering knowledge may have been far more advanced than we once believed. How do you think the ancient builders of Bandiagara managed to create mudstone structures that could survive for hundreds or even thousands of years on such steep cliffs? Share your thoughts or theories in the comments below. The Great Bath of Mohenjo-daro, located in present-day Pakistan, is widely regarded as one of the most remarkable and mysterious engineering achievements of the ancient Indus Valley civilization, which flourished roughly between 2600 and 1900 BCE. Discovered during major excavations led by Sir John Marshall and Ernest Mackay in the 1920s, the structure immediately captured the attention of archaeologists because it seemed far more technologically sophisticated than many other constructions from the same era. Even today, more than a century after its discovery, the Great Bath continues to puzzle researchers, particularly because of its astonishingly advanced waterproofing technology, its precise architectural planning, and the fact that the true purpose of the structure remains uncertain. The Great Bath itself is a large rectangular pool measuring approximately 12 meters long, 7 meters wide, and about 2.4 meters deep. Two symmetrical staircases descend into the pool from the north and south sides, and the entire structure is surrounded by a complex arrangement of corridors and small rooms that may once have served ritual or administrative functions. While the layout alone is impressive for a structure over 4,000 years old, what truly astonishes scientists is the extraordinary level of engineering hidden within the walls and floor of the pool. The builders used kiln-fired bricks laid with remarkable precision, following the standardized Indus brick ratio of 1:2:4 in thickness, width, and length. This level of material standardization suggests a sophisticated system of measurement and mass production that existed across the entire Indus civilization, from Mohenjo-daro to Harappa and beyond. However, the most fascinating and mysterious aspect of the Great Bath lies in its exceptionally advanced waterproofing system, which has baffled archaeologists for decades. The interior of the pool was not merely lined with bricks. Instead, the builders created a multi-layered structure designed specifically to prevent water leakage. Beneath the tightly fitted bricks, archaeologists discovered a thick layer of natural bitumen, a tar-like petroleum substance known for its water-resistant properties. This bitumen was carefully applied between brick layers, effectively sealing the entire pool basin. The presence of bitumen is particularly remarkable because Mohenjo-daro is located hundreds of kilometers away from major natural bitumen sources. Geological studies suggest that the material may have been transported from regions such as Baluchistan, implying long-distance trade networks and a clear understanding of the material's engineering value. What makes this discovery even more astonishing is that such deliberate waterproof construction is rarely seen in structures of comparable age. For example, many large stone monuments built in ancient Egypt around the same period, including temple complexes and tomb structures, did not rely on such elaborate waterproof sealing methods. Even in later civilizations, large water-retaining structures often struggled with leakage and erosion. The Roman Empire, which flourished more than 2,000 years later, is famous for its advanced hydraulic engineering, including aqueducts and baths sealed with waterproof mortar, known as opus signinum. Yet the Great Bath of Mohenjo-daro demonstrates that a civilization more than 2 millennia earlier had already developed a reliable solution for maintaining a large water basin without significant seepage. Excavations conducted in the early 20th century revealed further evidence of the builders' technical sophistication. The floor of the pool was constructed using 2 layers of baked brick set in gypsum mortar, with the bitumen layer sandwiched between them. This arrangement created a waterproof barrier that was both flexible and durable, capable of resisting the natural movement of soil and seasonal temperature changes. Archaeologists have noted that even after thousands of years of burial and exposure, large portions of the pool structure remain intact, a testament to the effectiveness of its original engineering. Some researchers have even suggested that the structural principles used in the Great Bath resemble modern waterproof construction techniques, where multiple protective layers are used to prevent moisture penetration. In addition to its waterproofing system, the Great Bath was connected to an advanced water management network. Nearby wells supplied clean water to the pool, while a sophisticated drainage system allowed the basin to be emptied and cleaned when necessary. The drain channels were constructed from tightly fitted bricks and were equipped with corbelled covers, preventing debris from clogging the system. This indicates that the builders understood not only how to store water but also how to manage its circulation and disposal, an important aspect of urban sanitation. In fact, many historians point out that the overall sanitation system of Mohenjo-daro, which included covered drains running along city streets, was far more advanced than the sanitation infrastructure found in many medieval cities thousands of years later. Another intriguing aspect of the Great Bath is the broader urban context in which it was built. Mohenjo-daro itself was an exceptionally well-planned city, laid out on a grid system with wide streets and standardized housing blocks. The Great Bath occupies a prominent position within what archaeologists call the Citadel area, a raised platform that likely housed important civic or ceremonial buildings. Its location suggests that the structure may have held special cultural or religious significance, rather than serving merely as a recreational pool. Many scholars believe it may have been used for ritual purification ceremonies, somewhat similar to the sacred bathing practices seen in later South Asian traditions, such as ritual bathing in the Ganges River. However, no inscriptions or definitive evidence have been found to confirm this theory. This absence of written explanations is one of the greatest mysteries surrounding the site. Unlike ancient Egypt or Mesopotamia, the Indus Valley script remains undeciphered, meaning researchers cannot rely on textual records to understand the intentions of its builders. As a result, the Great Bath stands as a silent monument to a civilization whose technological knowledge appears far more advanced than previously assumed. Despite decades of research and numerous archaeological expeditions, scholars still debate fundamental questions. How did the builders acquire such detailed knowledge of waterproof materials? How was the bitumen transported and processed? And why was so much effort invested in constructing such a perfectly sealed water structure? Today, the Great Bath of Mohenjo-daro remains one of the most remarkable relics of the ancient world. Its precise brickwork, advanced drainage system, and especially its mysteriously sophisticated waterproofing technology, challenge long-held assumptions about early urban engineering. Even after 4,000 years, the structure still stands as strong evidence that the Indus Valley civilization possessed architectural knowledge far more advanced than historians once believed. Where do you think the ancient Indus civilization learned such advanced waterproofing technology more than 4,000 years ago? Share your thoughts or theories in the comments below. Hidden deep within the deserts of northern Sudan lies one of the most mysterious architectural landscapes of the ancient world. The Meroe Pyramids, the royal burial ground of the powerful kingdom of Kush. Built between roughly 300 BCE and 350 CE, this vast necropolis contains more than 200 pyramids rising from the golden sands of Nubia. In fact, the region around Meroe contains a greater number of pyramids than Egypt itself. Yet despite their quantity and striking appearance, the pyramids of Meroe remain far less understood than their famous counterparts, such as the Great Pyramid of Giza. Archaeologists continue to investigate how the Kushite builders achieved such precise stone construction, unusual structural designs, and large-scale building programs in a harsh desert environment over 2,000 years ago. Among all the mysteries surrounding these monuments, perhaps the most intriguing is the extraordinary precision with which their stones were cut and assembled. Unlike the gigantic pyramids of Egypt, which were constructed from massive limestone blocks sometimes weighing several tons, the pyramids of Meroe were generally built using smaller sandstone blocks. At first glance, this might suggest simpler construction methods. However, closer examination has revealed a level of precision that is surprisingly sophisticated. Many of the stone blocks display flat surfaces, straight edges, and near-perfect right angles that allowed them to fit tightly together with minimal gaps. In several pyramids excavated by archaeologists during the 20th century, the joints between stones were measured to be only a few millimeters wide. This is remarkable considering that the builders were working with tools that were likely made of iron or bronze rather than modern steel-cutting equipment. Archaeological investigations carried out in the early 20th century by American archaeologist George Andrew Reisner from Harvard University and the Museum of Fine Arts Boston revealed detailed evidence of this stone craftsmanship. Reisner's expeditions between 1907 and 1910 carefully documented the masonry of numerous pyramids at Meroe. His field notes described stone courses laid with remarkable consistency, with blocks cut to uniform heights and lengths that allowed them to stack in stable layers despite the steep pyramid angle. Later surveys confirmed that some stones were shaped with surprising accuracy, suggesting that Kushite builders had developed reliable methods for measuring, cutting, and finishing sandstone blocks. One of the most puzzling aspects of the stonework is how these ancient craftsmen achieved such precise cuts. Sandstone, while softer than granite, is still difficult to shape accurately without advanced tools. Yet many of the blocks used in the Meroe pyramids appear to have smooth faces and squared edges. Some researchers believe the builders may have used a combination of iron chisels, stone hammers, and abrasion techniques involving sand. However, even with these methods, producing hundreds of evenly shaped blocks for each pyramid would have required remarkable skill and organization. The precision suggests the use of consistent measuring systems and possibly wooden templates or marking tools to guide the cutting process. Comparisons with Egyptian pyramid construction make the mystery even more intriguing. The pyramids at Giza, built roughly 2,000 years earlier, relied on massive limestone blocks placed in carefully leveled courses. In contrast, the pyramids at Meroe are far steeper, with slopes approaching 70 degrees compared to about 51 degrees at Giza. This steep design means that each layer of stone had to be positioned with particular accuracy to maintain structural stability. Any misalignment could have caused the outer faces to collapse or slide. Yet many of the pyramids remained standing for more than 2 millennia, demonstrating that the Kushite engineers had mastered the geometry and stone placement necessary to maintain such extreme angles. Archaeologists have also discovered evidence that the stones used in the pyramids were quarried from sources located several kilometers away from the construction sites. Transporting these blocks across desert terrain would have required organized labor and logistical planning. While the blocks are smaller than those used in Egypt, hundreds of them were still needed for each structure. Once transported, they had to be shaped precisely and positioned in carefully aligned courses. The outer layers of some pyramids were originally covered with finely finished casing stones, which would have created smooth surfaces reflecting sunlight across the desert landscape. Another fascinating discovery emerged during excavations in the late 20th century, when archaeologists began examining tool marks left on the stones. These marks revealed patterns consistent with repeated chisel strikes, suggesting controlled shaping rather than rough cutting. In certain blocks, faint guidelines appear to have been carved before the final shaping, possibly serving as markers for craftsmen to follow while cutting. This implies a level of planning and coordination among workers, with specific roles assigned for measuring, cutting, transporting, and placing the stones. Despite these discoveries, many questions remain unanswered, and no surviving texts from the Kingdom of Kush describe the methods used to construct the pyramids. Unlike Egypt, where inscriptions and reliefs sometimes depict building activities, the Kushite pyramids provide very few clues about the construction process itself. Much of the knowledge about their techniques must therefore be reconstructed from archaeological evidence alone. Complicating matters further, many of the pyramids were heavily damaged during the 19th century by treasure hunters searching for gold and artifacts. One of the most notorious figures associated with this destruction was the Italian explorer Giuseppe Ferlini, who in 1834 used explosives to blast open the tops of several pyramids. Although he eventually discovered jewelry belonging to a Kushite queen, the damage destroyed valuable archaeological information about the original structures. As a result, some of the most important evidence regarding how the pyramids were built may have been lost forever. Modern archaeological surveys using drone photography, 3D scanning, and satellite imagery are now providing new insights into the site. These technologies have allowed researchers to map the entire necropolis with remarkable precision, revealing patterns in pyramid placement and orientation. Some pyramids appear to align with others in carefully planned arrangements, suggesting that their builders were not only skilled stonemasons, but also knowledgeable in geometry and spatial planning. Today, the Mehrgarh pyramids stand as remarkable evidence of an advanced civilization whose engineering knowledge is still not fully understood. Their steep forms differ greatly from the Great Pyramid of Giza, yet the precision with which their sandstone blocks were cut and fitted continues to puzzle archaeologists. How did craftsmen more than 2,000 years ago achieve such accuracy with relatively simple tools? And how did they organize the labor needed to build more than 200 pyramids in the harsh Nubian desert? Despite modern research, the full construction techniques of the Kushite builders remain unknown, leaving the pyramids of Meroe as one of the enduring mysteries of ancient engineering. How do you think ancient builders managed to cut and fit these stones so precisely over 2,000 years ago? Rising from a windswept plateau in the Sunik province of southern Armenia, the mysterious stone complex known as Zorats Karer, often called Karahunj, stands as one of the most puzzling prehistoric monuments in the Caucasus. Spread across an area of roughly 7 hectares, the site contains more than 220 massive standing stones, arranged in a combination of circular and linear formations. Archaeologists frequently compare it to Stonehenge in Britain because of its ring-like structure and the apparent astronomical orientation of several stones. Yet Zorats Karer possesses a technological feature that sets it apart from nearly every other megalithic monument on Earth. Dozens of the stones contain precisely drilled circular holes carved directly through extremely hard volcanic basalt. These enigmatic perforations have become one of the greatest technical mysteries associated with the site, and have sparked decades of debate among archaeologists, engineers, and astronomers alike. The monument itself consists primarily of tall basalt monoliths, ranging from about 1.5 to 3 meters in height, with some weighing as much as 8 to 10 tons. Many of these stones form a rough central circle, approximately 40 to 45 meters in diameter, while others extend outward in long alignments that stretch over 100 meters across the plateau. From above, the entire layout appears surprisingly deliberate, suggesting a carefully planned architectural design rather than a random arrangement of stones. However, what truly captures the attention of researchers are the approximately 80 stones that contain round holes drilled through them. These openings are generally between 4 and 5 centimeters in diameter and can extend 20 to 40 centimeters deep into the rock. Considering the geological nature of basalt, this detail alone raises extraordinary questions about the technology used by the builders. Basalt is an igneous rock, formed from cooled volcanic lava, and is widely recognized for its density and durability. On the Mohs hardness scale, basalt typically ranks around 6, meaning it is significantly harder than many types of limestone or sandstone commonly used in ancient construction. Even with modern tools, drilling clean cylindrical holes through basalt requires specialized equipment and high-pressure rotary drills tipped with hardened steel or diamond. The presence of dozens of such holes in the stones of Zorats Karer suggests a level of precision and effort that seems surprisingly advanced for a prehistoric society that may have existed several thousand years ago. If the site dates to the early Bronze Age, as some excavations suggest, roughly between 2000 and 3000 BCE, it would imply that ancient builders were capable of executing complex drilling operations on extremely hard stone, using tools that have not yet been identified in the archaeological record. During several archaeological investigations carried out in the 20th century, researchers closely examined the surfaces of these drilled openings. Instead of rough chisel marks typically produced by hammering techniques, the holes often appear smooth and remarkably circular, leading some specialists to propose that they may have been created using a rotating drilling method. One theory suggests that ancient craftsmen could have used copper or bronze tubes combined with abrasive materials such as quartz sand to gradually grind through the basalt. This technique is known to have been used in ancient Egypt to drill holes in granite and other hard stones. However, granite drilling in Egyptian monuments often required sophisticated tools and considerable labor, and even there, the holes sometimes show irregularities. At Zorats Karer, the uniformity of several perforations has raised doubts about whether such primitive methods alone could account for the level of accuracy observed. The mystery deepens when researchers consider the orientation of these holes. Many of them are not randomly positioned, but appear to face specific directions across the surrounding landscape or toward the sky. In the 1990s, Armenian physicist and astronomer Paris Hiruni conducted an extensive study of the site and proposed that Zorats Karer functioned as an ancient astronomical observatory. According to his research, several of the drilled openings align with the positions of prominent stars and the rising or setting points of the sun during solstices and equinoxes. When observers look through certain holes, the line of sight appears to correspond with celestial events that would have been visible thousands of years ago. Hiruni argued that the monument might date as far back as 7,500 years, Dana potentially making it older than Stonehenge by several millennia. While many archaeologists remain skeptical of such early dates, the astronomical hypothesis continues to generate interest because the drilled holes could theoretically have served as primitive sighting instruments. Another factor that complicates the puzzle is the sheer effort required to transport and erect the stones themselves. Each monolith had to be quarried, moved across uneven terrain, and positioned upright with considerable precision. Some stones weigh several tons, and the nearest natural basalt sources are not always located immediately beside the site. Without evidence of advanced machinery, wheels, or metal lifting devices, prehistoric builders would have had to rely on wooden sledges, ropes, and coordinated labour to move the massive blocks into place. Comparable feats are known from other megalithic monuments around the world, such as Stonehenge in England or the massive stone walls of Sacsayhuaman in Peru. Yet the additional step of drilling carefully oriented holes through the stones introduces a technological complexity rarely seen in similar structures. Excavations conducted during the Soviet period and later archaeological surveys have uncovered traces of Bronze Age burial mounds around parts of the complex, suggesting that the area may have served multiple functions over time. Some scholars believe the monument was originally a ceremonial or ritual centre that later became associated with burial practices. Others maintain that its layout and drilled stones indicate a deliberate astronomical purpose. Because many stones remain partially buried and erosion has altered parts of the site, it is difficult to reconstruct the monument's original appearance or determine exactly how it was used. What remains undeniable, however, is that the drilled basalt holes represent a remarkable engineering challenge for any ancient culture. Today, Zorats Karer still puzzles researchers. Despite modern scans and geological studies of the drilled holes, no clear explanation exists. How ancient builders drilled such precise holes in hard basalt remains one of the great technological mysteries of the ancient world. How do you think ancient people were able to drill such precise round holes through extremely hard basalt thousands of years ago? Share your thoughts or theories in the comments below. Hidden high in the Orăști Mountains of modern Romania lies Târgu Regia, the ancient capital of the Dacian kingdom and one of the most mysterious archaeological sites in Europe. Built roughly between the 1st century BCE and the early 2nd century CE during the reigns of Dacian rulers such as Burebista and later Decebalus, the complex once served as both a political stronghold and a sacred religious centre for the Dacian civilization. Today, it forms part of the UNESCO World Heritage-listed Dacian fortresses of the Orăști Mountains, protected by UNESCO. At an altitude of roughly 1,200 metres above sea level, the site stretches across a series of carefully engineered mountain terraces containing temples, sanctuaries, fortifications, and infrastructure systems that continue to puzzle historians and engineers alike. While many aspects of Târgu Regia remain enigmatic, including its astronomical sanctuaries and the famous andesite sun monument, the most intriguing mystery may lie in the fortress walls themselves, constructed using a highly sophisticated technique known as Murus Dacicus, a building method whose engineering complexity still raises questions about the technological capabilities of the Dacians more than 2,000 years ago. The Murus Dacicus system represents one of the most unusual defensive construction techniques in the ancient world. Unlike the simple stacked stone walls used by many early cultures, Murus Dacicus was a hybrid engineering system combining massive cut stone blocks with an internal framework of timber beams and a packed core of rubble and earth. Archaeological studies conducted during excavations throughout the 20th and 21st centuries reveal that the walls typically consisted of two outer faces made from carefully shaped limestone blocks, each block weighing several hundred kilograms. These blocks were arranged in tight horizontal rows without the use of mortar. Between these outer layers, builders inserted a core of compacted stone fragments and soil that created both mass and stability. Running through this structure were horizontal wooden beams that tied the outer stone faces together, essentially acting as structural anchors that prevented the walls from collapsing outward under pressure. This combination of rigid stone and flexible timber allowed the walls to absorb shock and vibration, a design that modern engineers note is surprisingly resistant to seismic activity and siege damage. Excavations carried out in the 1950s, 1960s, and again in major research campaigns beginning in the 1990s, reveal that some sections of the fortress walls were more than 3 meters thick and rose several meters high along the steep mountain slopes. The precision of the stonework is particularly striking. Many of the limestone blocks display flat surfaces and right-angled edges that appear to have been carefully cut and shaped before being transported to the site. In some areas, archaeologists measured joints between stones that are so tight that inserting even a thin metal blade between them is difficult. Even this level of precision has often been compared to the famous stonework of Sacsayhuaman or the masonry seen at Machu Picchu, both of which are renowned for their mortarless construction. Yet the Murus Dacicus system differs in one crucial aspect. Rather than relying solely on perfectly interlocking stones, the Dacians integrated a complex timber reinforcement framework that created a composite wall structure, unlike anything found elsewhere in Europe during the same period. Another puzzling aspect of Murus Dacicus involves the tools and techniques used to shape the stones. Archaeologists have discovered iron chisels, hammers, and other metalworking tools at the site, suggesting that the Dacians possessed advanced metallurgical knowledge. However, experimental archaeology has shown that shaping large limestone blocks with such tools would require an enormous amount of time and labour. Some blocks used in the fortifications measure over 0.5 metre in length and weigh hundreds of kilograms, raising questions about how they were cut so precisely and transported up the steep mountainous terrain. The fortress itself sits deep within the forested Carpathian landscape, far from major limestone quarries. This implies that either the Dacians transported the stones over long distances or quarried them locally and moved them up the mountain slopes using techniques that remain poorly understood. Archaeological surveys conducted during the early 2010s identified possible quarry sites nearby, but the exact logistics of the transport process, especially without evidence of large-wheeled vehicles capable of navigating the rugged terrain, remain uncertain. The engineering brilliance of Murus Dacicus becomes even more impressive when viewed in the broader context of the fortress complex. Samizgatusa Regia was not simply a single fortification, but rather a sophisticated urban and ceremonial centre, consisting of multiple terraces carved directly into the mountainside. Each terrace supported different functions, including religious sanctuaries, residential areas, workshops, and defensive structures. The massive fortress walls built with Murus Dacicus protected the upper plateau, where the most sacred and politically significant structures were located. Among these was the famous circular sanctuary complex often compared to Stonehenge, consisting of concentric rings of stone and wooden pillars that some researchers believe may have functioned as a solar calendar or astronomical observatory. Nearby lies the enigmatic andesite sun, a circular stone platform approximately 7 meters in diameter, carved from volcanic andesite and etched with radial grooves. Some scholars have suggested it may have functioned as a primitive solar timekeeping device, though its exact purpose remains debated. Despite these remarkable achievements, the Dacian capital met a violent end during the Roman campaigns led by Emperor Trajan. Historical accounts from Roman sources describe the destruction of the city in the year 106 CE, following the conquest of the Dacian kingdom. Archaeological layers at the site confirm extensive burning and structural collapse consistent with a large-scale military assault. Yet even after the fortress was destroyed, the engineering of Murus Dacicus continued to fascinate later historians. Roman engineers themselves reportedly studied the fortifications during the campaign, recognizing the unusual defensive strength of the walls. Some modern military historians argue that the Murus Dacicus system may have been partially inspired by earlier Mediterranean fortification techniques, while others believe it represents an independent technological innovation developed by the Dacians. More than 2,000 years later, the ruins of Samosagatusa Regia still reveal the remarkable engineering of the Dacians. The Murus Dacicus walls, built with massive stone blocks and hidden wooden reinforcements, created a structure that was both strong and flexible. Yet many questions remain. How did the Dacians cut the stones so precisely and transport them high into the mountains? These unanswered mysteries continue to make Samosagatusa Regia one of the most intriguing engineering achievements of the ancient world. How do you think the Dacians were able to build the Murus Dacicus walls with such precision and strength more than 2,000 years ago? Share your thoughts or theories in the comments below. Hidden in the lush highlands of western Panama, near the fertile slopes of the Baru volcano, lies one of Central America's most enigmatic archaeological sites, Panama Sitio Barriles. Dating roughly from around 300 BCE to 600 CE, this mysterious ceremonial center belonged to a pre-Columbian culture in the Chiriquí region long before the arrival of Europeans. At first glance, Sitio Barriles may appear modest compared with monumental civilizations such as the Maya or the Inca. Yet the discoveries unearthed there during decades of excavation reveal a puzzling level of craftsmanship and symbolic complexity that continues to intrigue archaeologists. Among the most fascinating elements of the site are its unusual stone sculptures, ceremonial platforms, and carved monuments. However, the aspect that draws the greatest scientific attention is the remarkably precise stone carving technology used by its ancient inhabitants, technology that raises significant questions about the tools, methods, and knowledge available to a culture that supposedly relied mainly on stone implements. The site first attracted widespread academic interest during the 1940s, when local farmers clearing land in the Chiriquí Highlands began uncovering strange carved statues and petroglyphs embedded in the soil. These discoveries soon caught the attention of researchers, including archaeologists associated with the Smithsonian Institution, who initiated systematic investigations in the region. Subsequent excavations carried out during the 1950s and 1970s revealed that the area had once been a thriving ceremonial and residential complex. Archaeologists uncovered stone foundations, paved pathways, pottery fragments, tools, and, most strikingly, dozens of carved stone sculptures. Radiocarbon dating of associated organic materials suggested that the site was occupied for several centuries, beginning roughly around 300 BCE and continuing into the early centuries of the Common Era. This timeline places Sitio Barriles among the earliest complex cultural centers in the region. Yet what truly sets Sitio Barriles apart from other archaeological sites in Panama is the extraordinary craftsmanship of its carved stone artifacts. Many of these sculptures are carved from basalt and andesite, volcanic rocks known for their extreme hardness. Basalt, for example, typically measures around 6 on the Mohs hardness scale, making it significantly harder than limestone, the material commonly used by ancient civilizations such as the Maya for temple construction. Carving such rock with simple stone tools would have required immense effort and remarkable technical skill. Nevertheless, the artisans of Sitio Barriles managed to produce sculptures with smooth surfaces, balanced proportions, and detailed facial features, suggesting a sophisticated understanding of stoneworking techniques. Perhaps the most famous sculptures from the site are the so-called carrier statues, which depict a human figure carrying another person on its back. These statues, sometimes reaching heights of over 1.5 meters and weighing several hundred kilograms, display astonishingly detailed carvings. The faces often show expressive eyes, defined noses, and stylized mouths, while the bodies reveal carefully shaped limbs and belts. In several examples, the individual being carried appears smaller and more rigid, as if symbolizing a captive, ancestor, or spiritual entity. The precise symbolism of these sculptures remains uncertain, but their craftsmanship is undeniable. The surfaces show clear evidence of deliberate shaping and polishing, and the symmetry of the figures suggests careful planning rather than crude carving. Even more intriguing are the petroglyphs and carved stone slabs discovered throughout the site. These stones feature geometric motifs, spiral patterns, animals, and human faces etched with striking precision. Many of the carved lines maintain a consistent depth and width, implying controlled carving techniques rather than random chiseling. Some researchers have noted that certain grooves appear to have been cut with such regularity that they resemble marks produced by metal tools, even though there is no clear evidence that the Barriles culture possessed advanced metallurgy. The apparent paradox raises an important question. How did these ancient artisans achieve such accuracy using only stone or bone tools? Comparisons with other ancient stoneworking traditions highlight the mystery even further. In Sacsayhuaman in Peru, the Inca famously shaped massive stone blocks with astonishing precision, but they possessed a highly organized labor system and sophisticated engineering knowledge. Similarly, the megalithic structures at Pumapunku in Bolivia display carefully cut stone surfaces and geometric carvings that continue to puzzle researchers. Yet Sitio Barriles predates many of these achievements and was created by a society believed to be smaller and less centralized. Despite this, the carvings show a comparable level of attention to detail on a smaller scale. Some scholars have suggested that repeated grinding with harder stones or abrasive sand might explain the precision, but replicating the exact results experimentally has proven extremely difficult. The arrangement of carved stones within the site adds another layer of mystery. Excavations revealed that many statues and carved slabs were positioned within a central ceremonial area surrounded by stone foundations. Some stones appear aligned along pathways or plazas, suggesting they played a role in ritual gatherings. In several locations, archaeologists discovered large flat stones shaped into what appear to be ceremonial seats or platforms. These stones also display polished surfaces and carved motifs, implying that they were intentionally designed rather than naturally formed. The placement of these seats around open spaces has led researchers to speculate that they may have been used by religious leaders or elite members of society during public ceremonies. Further excavations uncovered a wide range of artifacts that shed light on the broader culture of the Barriles people. Pottery fragments found at the site exhibit intricate decorations and distinctive forms characteristic of the Greater Cherokee cultural tradition. Some ceramic vessels show painted designs and carefully molded shapes, demonstrating advanced pottery techniques. Stone tools and grinding implements were also discovered, indicating that the inhabitants possessed a well-developed craft economy. However, despite these discoveries, many aspects of the culture remain poorly understood. The language spoken by the inhabitants is unknown, and their political organization remains largely speculative. One particularly puzzling aspect of Sitio Barriles is the apparent combination of artistic sophistication and technological simplicity. On one hand, the society appears to have relied primarily on stone tools and traditional crafting methods. On the other hand, the carvings produced at the site demonstrate a level of precision that rivals the stone art of more technologically advanced civilizations. This contradiction has sparked debate among archaeologists for decades. Some researchers argue that the carvings represent the culmination of centuries of accumulated craftsmanship, refined through generations of artisans. Others suggest that the techniques used may have involved specialized knowledge, perhaps lost over time, that allowed workers to shape extremely hard stone with surprising efficiency. Modern archaeological studies continue to examine the site using improved analytical methods. Laser scanning and microscopic analysis of carving marks have been used to study the surfaces of several statues, whereas these investigations have revealed evidence of repetitive grinding and controlled percussion techniques, indicating that artisans likely used combinations of hammer stones and abrasive materials. Even so, the time and labour required to produce these sculptures would have been enormous. Creating a single statue from basalt could have taken weeks or even months of continuous work, especially if only stone tools were available. How do you think the ancient people of Sitio Barriles were able to carve such precise shapes into extremely hard volcanic stone using only simple tools? Share your thoughts in the comments below. Across the rocky landscapes of the Balearic Islands of Spain, particularly on the islands of Mallorca and Menorca, stand hundreds of massive prehistoric stone towers known as the Talaiots. These mysterious structures were built during what archaeologists call the Talaiotic period, roughly between 1200 BCE and 500 BCE, long before the Roman Empire arrived in the Western Mediterranean. At first glance, Talaiot Tower appear to be simple piles of stone, but closer examination reveals that they are among the most intriguing megalithic constructions in Europe. Their enormous stones, carefully balanced architecture, and strategic placement across the islands have puzzled archaeologists for more than a century. Despite extensive excavations and modern scientific analysis, and many aspects of how and why these structures were built remain unresolved, particularly the possibility that their placement may have been connected to astronomical observations. Talaiot towers are typically circular or sometimes square structures built from enormous limestone blocks, using a technique known as cyclopean masonry. The stones were stacked without mortar, yet the towers have survived for more than 3,000 years. Many talaiots measure between 8 and 12 meters in diameter and can reach heights of up to 10 meters. Some of the individual stones weigh several tons, raising immediate questions about how prehistoric builders managed to transport and position such massive blocks using what were likely relatively simple tools. Unlike later Mediterranean cultures, certain early Talaiotic communities did not yet possess advanced metal tools or complex lifting machinery. Archaeologists believe that the stones were quarried locally, but the methods used to shape and move them remain uncertain. The precision with which some of these stones fit together suggests a sophisticated understanding of balance and structural stability. Comparable techniques can be seen in other megalithic traditions around the Mediterranean, such as the Mehrgarh towers of Sardinia or the massive polygonal stone walls of Sacsayhuaman in Peru, yet the Talaiots appear to represent a unique regional development, rather than a direct copy of any known architectural tradition. The internal design of many Talaiots adds further complexity to the mystery. Some towers contain a central stone column supporting horizontal slabs that may once have formed an upper chamber or roof. In other examples, narrow corridors lead into small interior spaces whose purpose is still debated. Early archaeologists in the late 19th and early 20th centuries suggested that the towers served as defensive watchtowers or fortified structures designed to monitor surrounding territory. However, this explanation does not fully match the archaeological evidence. Many Talaiots are located in areas that do not offer clear strategic advantages, and their internal chambers are often too small to accommodate large groups of defenders. Excavations conducted during the 20th century, particularly those led by Spanish archaeologists such as Josep Mascaró Pasarius and later by international research teams, began to suggest that Talaiots may have served ceremonial or communal functions rather than purely military ones. One of the most fascinating and controversial aspects of the Talaiot towers is the possibility that their positioning was deliberately connected to astronomical phenomena. Over the past few decades, Archaeologists and archaeoastronomers have noticed patterns in the orientation and placement of several Talaiotic structures. Some talaiots appear to align with important solar events such as the sunrise or sunset during the summer solstice or winter solstice. This has led researchers to propose that these towers may have functioned not only as social or ceremonial centres, but also as markers within a broader system of astronomical observation. On the island of Minorca, for example, several Talaiotic settlements are located near another type of mysterious structure known as Taula sanctuaries. These T-shaped stone monuments are thought to have had ritual significance, and some studies suggest that the orientation of the Taula structures corresponds with the rising positions of certain stars visible in the Mediterranean sky during the Late Bronze Age. Archaeological surveys conducted in the late 20th and early 21st centuries have provided additional evidence that supports the astronomical interpretation. Researchers analysing satellite imagery and site mapping have found that clusters of talaiots often appear in spatial arrangements that may reflect deliberate planning rather than random settlement growth. In certain locations, as lines drawn between multiple talaiots correspond closely with the direction of solstice sunrises or sunsets. Although these alignments are not universal across all talaiot sites, the repeated pattern in several regions has sparked growing interest among scientists studying prehistoric astronomy. Similar phenomena are well known in other ancient cultures. The famous stone circle of Stonehenge in England, for instance, aligns precisely with the sunrise during the summer solstice, while the prehistoric passage tomb of Newgrange in Ireland is illuminated by sunlight only during the winter solstice sunrise. Even in the Americas, structures such as the Cahokia Woodhenge in North America functioned as solar calendars used to track seasonal cycles. The possibility that Talaiot towers formed part of a similar observational system raises intriguing questions about the intellectual world of the Talaiotic people. Tracking the movement of the sun and stars would have been extremely valuable for agricultural societies attempting to predict seasonal changes. Knowing the timing of solstices and equinoxes could help determine when to plant crops, hold ceremonies, or organize communal activities. Yet the challenge lies in proving intentionality. Alignments can sometimes occur by coincidence, and archaeologists must carefully evaluate whether patterns are statistically meaningful. Still, the repeated presence of astronomical orientations in multiple Talaiotic sites suggests that at least some builders were paying close attention to the sky. Excavations conducted during the early 21st century have also revealed that Talaiotic settlements were far more complex than previously believed. In addition to the towers themselves, many sites include extensive stone houses, defensive walls, and ceremonial structures. At the large settlement of Son Fornès in Majorca, archaeologists discovered layers of habitation dating back more than 3,000 years. Radiocarbon dating and artifact analysis indicate that the community maintained organized construction projects and likely had a hierarchical social structure capable of mobilizing large groups of workers. Building even a single talaiot would have required the coordinated effort of dozens, possibly hundreds of people. This suggests that Talaiotic society possessed a level of organization comparable to other Bronze Age cultures around the Mediterranean. Despite many discoveries, major mysteries about the Talaiot civilization still remain. No written records have been found, so archaeologists must rely only on physical remains. The true purpose of many Talaiot towers is still debated, with theories ranging from defensive watchtowers to ceremonial or astronomical structures. Today, more than 500 Talaiot structures have been identified across the Balearic Islands, many still well preserved. They remain one of the most intriguing archaeological mysteries in the Mediterranean world. If the Talaiot towers were truly designed to track the sun and stars more than 3,000 years ago, What do you think that says about the scientific knowledge of the ancient people who lived on these small islands? Share your thoughts in the comments below. Hidden deep within a lush river valley on the Indonesian island of Bali lies one of Southeast Asia's most puzzling archaeological sites, the ancient complex of Gunung Kawi Temple Complex. Carved dramatically into the steep cliffs along the sacred Pakeresan River, this remarkable monument dates back to approximately the 11th century and is widely associated with the royal dynasty of the Balinese king Udayana Wamadewa and his descendants. Although Gunung Kawi is often described as a temple complex, its construction method alone places it among the most unusual ancient structures in the world. Rather than being assembled from blocks of stone like most temples across Asia, the shrines here were created through a radically different process. They were carved directly into the solid volcanic rock of the cliff itself. This technique, known as rock-cut architecture, required ancient craftsmen to remove enormous quantities of stone while simultaneously shaping intricate architectural forms with remarkable precision. The site consists of 10 monumental shrines, each rising roughly 7 meters high, arranged in 2 dramatic groups on opposite sides of the valley. 5 of the shrines stand in a row on the eastern cliff face, while 4 more appear across the river on the western side, with a final isolated shrine nearby. From a distance, they resemble towering temple facades embedded in the mountain, as if entire sanctuaries had been frozen inside the rock. What makes these structures particularly mysterious is the sheer difficulty of the technique used to create them. Unlike masonry temples where stones can be shaped individually and assembled later, rock-cut monuments require the builders to work from the top downward, carefully removing stone without making mistakes that could ruin the entire structure. Once carved, the design cannot be corrected. Archaeologists estimate that creating just one of the shrines would have required removing hundreds of tons of rock from the cliff face. When multiplied by 10 monuments and additional surrounding chambers, the total amount of stone removed from the valley likely reached several thousand tons. Yet no clear evidence of large debris fields or organised quarry dumps has been identified near the site, leaving researchers uncertain about how the ancient builders managed the massive volume of excavated material. The precision of the carvings is equally striking. The shrines are not rough recesses in the rock. Yes, they are carefully sculpted architectural facades that imitate the multi-tiered towers typical of ancient Javanese and Balinese temple design. The vertical lines of the structures are remarkably straight, their proportions balanced, and their decorative ledges evenly spaced. Measurements taken during archaeological surveys in the 20th century show that the shrines follow consistent geometric proportions, despite being carved into uneven cliff surfaces. Maintaining such symmetry would have required careful planning and skilled execution, especially considering that the workers were likely standing on wooden scaffolding attached to a near-vertical rock wall. Even today, achieving this level of precision using only basic hand tools would be a formidable engineering challenge. The first systematic archaeological investigations of Gunung Kawi began during the Dutch colonial period in the early 20th century, when European researchers surveying Bali's ancient monuments documented the site's unusual architecture. Later excavations in the 1950s and 1970s provided additional insights into its history and religious function. Scholars concluded that the complex was probably built as a royal memorial site, honouring members of the Wamadewa dynasty. Inscriptions discovered nearby refer to a king named Anak Wungsu, a ruler of Bali in the 11th century, whose family lineage may be commemorated by the shrines carved into the cliffs. However, even if the site served as a funerary monument, the decision to construct it in such a technically demanding way remains puzzling. In other parts of Southeast Asia during the same period, temples were typically built using stacked stone or brick, which allowed builders to expand and modify structures more easily. Choosing instead to carve entire temple facades directly into a mountain required far more labour and planning. Comparisons with other rock-cut monuments around the world only deepen the mystery. Sites such as the caves of Ajanta Caves or the temples of Ellora Caves in India demonstrate that ancient civilizations were capable of carving elaborate sanctuaries from solid stone. However, those complexes often contain dozens of chambers extending deep into the rock. Gunung Kawi is different. Its shrines are monumental facades exposed to the open valley, almost like giant relief sculptures carved into the cliff. In this sense, it resembles the rock-cut tombs of Petra in Jordan, yet Petra's facades were carved into relatively softer sandstone, while the cliffs of Gunung Kawi consist largely of volcanic tuff, hardened by centuries of geological processes. This material is significantly more difficult to shape with simple tools, raising further questions about the techniques employed by the builders. Another intriguing aspect of Gunung Kawi is the arrangement of the shrines across the valley. Rather than forming a single temple compound, the monuments are divided between two cliffs separated by the Pakerison River. Archaeologists have proposed that this symmetrical placement may have had symbolic meaning connected to Balinese cosmology, which often emphasizes balance between opposing forces in nature. The river itself was considered sacred, and its presence may have played a role in purification rituals associated with royal memorial ceremonies. However, no definitive explanation has been found to confirm why the shrines were positioned exactly where they are. Surrounding the main monuments are additional carved features that deepen the site's mystery. Small caves and meditation chambers are cut into the rock walls near the shrines, some containing stone platforms that may have served as places for hermits or priests to sit during religious practices. Narrow stairways and terraces carved into the hillside suggest that the entire valley may once have been an integrated ceremonial landscape rather than a single isolated monument. Excavations have also uncovered fragments of ancient irrigation channels nearby, hinting that the surrounding environment was carefully managed as part of a broader sacred complex linked to Bali's traditional water temple culture. Despite decades of research, many questions remain unanswered. Archaeologists still debate how long the construction of Gunung Kawi actually took. Some estimates suggest that hundreds of workers could have spent decades carving the shrines, while others argue that the consistent style of the carvings implies a shorter, more concentrated building campaign. The tools used by the craftsmen are also uncertain. Iron chisels were known in the region during the 11th century, but the durability required to carve such large and uniform structures in volcanic rock would have demanded exceptional skill and organization. Today, thus, the Gunung Kawi temple complex remains one of Indonesia's most remarkable archaeological sites. Towering shrines carved directly into the cliffs rise above the jungle valley, creating a scene that feels almost timeless. Despite decades of research, one mystery still remains. How did a civilization more than 1,000 years ago carve such precise monuments into solid rock, using the limited tools of their time? So how do you think ancient people more than 1,000 years ago managed to carve gigantic temples directly into solid cliffs with such incredible precision? Share your thoughts or theories in the comments below. Rising unexpectedly from the plains of northern Sardinia, not far from the modern city of Sassari, the prehistoric monument known as Monte d'Acodi remains one of the most puzzling archaeological structures in Europe. Built roughly between 4000 and 3650 BCE, long before the rise of classical Mediterranean civilizations, the monument defies conventional expectations of what Neolithic societies in Europe were capable of constructing. At first glance, Monte d'Acodi resembles a stepped pyramid or raised ceremonial platform, an architectural style far more commonly associated with the ancient temples of Mesopotamia than with prehistoric communities in the Western Mediterranean. Because of this resemblance, many scholars have compared it to structures such as the ziggurat of Ur, even though Sardinia lies thousands of kilometers away from the heartland of early urban civilizations. The monument consists of a massive rectangular platform, approximately 27 meters on each side, and rising about 10 to 12 meters above the surrounding landscape, accessed by a long ceremonial ramp stretching roughly 40 meters in length. Archaeological excavations have revealed that this impressive structure was not built all at once, but rather developed in phases, indicating that the builders possessed not only technical skill, but also long-term planning and a surprisingly organized social system capable of sustaining large construction projects across generations. One of the most intriguing aspects of Monte Dacicus, and the one that continues to puzzle researchers the most, is the enormous artificial foundation upon which the entire structure was constructed. Unlike many prehistoric monuments that rely directly on natural rock outcrops, Monte Dacicus sits upon a carefully engineered base composed of multiple layers of materials including limestone blocks, basalt fragments, gravel, clay, and compacted earth. Archaeological surveys indicate that thousands of tons of stone and soil were deliberately transported and arranged to create a stable platform capable of supporting the upper terrace and ceremonial structures. Radiocarbon dating of organic materials discovered during excavations suggests that the earliest phase of construction began around 4000 BCE, during the late Neolithic Ozieri cultural period. This dating became clearer after systematic excavations carried out in the 1950s and 1960s under the direction of Italian archaeologist Ercole Contu, who uncovered evidence that the original structure had been partially destroyed and then rebuilt on a larger scale. The second phase dramatically expanded the platform, adding more layers of stone and soil to reinforce the base and creating the monumental ramp that still dominates the site today. The engineering challenge involved in constructing such a foundation becomes even more impressive when one considers the technological limitations of the time. The people responsible for Monte Dacicus lived thousands of years before the widespread use of metal tools, before advanced construction equipment, and likely before the wheel was commonly used in the region. Yet they managed to transport and organize massive quantities of raw material across open terrain. Some of the stones used in the base weigh several hundred kilograms, and geological analysis suggests that many were not collected directly at the construction site, but were instead brought from surrounding areas several kilometers away. In total, researchers estimate that the foundation of the monument alone may contain well over 2,000 tons of combined stone and packed sediment. To place this into perspective, this amount of material is comparable to the mass used in the construction of some smaller ancient pyramidal platforms in the Near East. Despite the fact that the Sardinian builders were operating within a much smaller and less urbanized society, what makes the foundation particularly mysterious is the way in which different materials were combined to create structural stability. Excavations reveal alternating layers of large stones, crushed rock, and compacted soil, forming something that resembles a primitive but effective system of load distribution. Modern geotechnical engineers studying the site have noted that such layered construction helps prevent subsidence and improves the durability of large platforms over long periods of time. In effect, the builders created a kind of prehistoric composite foundation capable of supporting significant weight while adapting to minor ground movement. This technique is remarkably sophisticated for a Neolithic community and raises questions about how the builders acquired the knowledge necessary to design such a structure. Unlike later civilizations that left written records or architectural manuals, the people who built Monte Dacicus left behind no text explaining their methods. Their engineering expertise must therefore be reconstructed solely from the physical evidence preserved in the monument itself. Comparisons with other ancient structures highlight just how unusual Monte Dacicus truly is. In most parts of Neolithic Europe, large constructions took the form of megalithic tombs, stone circles, or standing stones. Sites such as the Passage tomb complexes of Ireland or the dolmens scattered across Western Europe typically relied on a limited number of massive stones placed directly on natural ground surfaces. By contrast, Monte Dacicus represents a deliberate attempt to reshape the landscape by building an enormous artificial platform from the ground up. In this sense, it shares conceptual similarities with the ziggurats of Mesopotamia, which were also constructed using layered materials such as mud brick and rubble to form large stepped terraces. However, the Mesopotamian examples belong to societies that possessed writing systems, organized labor forces, and well-documented religious traditions. The Neolithic communities of Sardinia appear far less complex on the surface, yet the monument they left behind suggests a level of technical capability that rivals early temple architecture elsewhere in the ancient world. Further discoveries around the site reinforce the impression that Monte Dacicus served as an important ceremonial centre. Archaeologists have uncovered a large rectangular stone altar near the base of the ramp, along with a massive spherical boulder weighing approximately 8 to 10 tons, and a tall menhir standing more than 4 meters high. Animal bones found in the surrounding soil indicate that ritual sacrifices may have taken place here, possibly during communal gatherings. The careful placement of these stones also hints at deliberate planning and spatial organization, suggesting that the builders viewed the entire complex as a sacred landscape rather than merely a single structure. Some researchers have proposed that the orientation of the ramp and platform may have had astronomical significance, perhaps aligning with the rising sun during particular seasonal events, although this hypothesis remains debated within the academic community. Despite decades of research, Monte Dacicus still puzzles archaeologists. The monument has survived more than 5,000 years, proving the effectiveness of its layered stone and earth foundation. Yet key questions remain. How did a society without metal tools move thousands of tons of material and build such a stable platform? And why does its design resemble temple structures from distant civilizations? In your opinion, how were Neolithic people able to transport thousands of tons of stone and build the massive foundation of Monte Dacicus without metal tools or modern machinery? Share your thoughts or theories in the comments below. In the vast plains of southwestern Iran, far from the towering monuments of Egypt and the well-preserved ruins of Mesopotamia, lies a site that, at first glance, appears almost unremarkable. A series of low, weathered mounds stretching across the land. This is Anshan, known today as Tali Malian, once one of the most powerful capitals of the ancient Elamite civilization. Unlike other great cities of antiquity, Anshan does not impress with grand stone temples or towering columns. It does not dominate the horizon like Babylon or Persepolis. Instead, it seems to dissolve into the earth itself, as if time has slowly and deliberately erased its presence. And yet, beneath this quiet and almost invisible surface lies a city that once shaped the political and cultural landscape of the ancient Near East. A city whose story is still incomplete, fragmented and filled with unanswered questions. Anshan was not a peripheral settlement. It was a vast urban centre covering hundreds of hectares, with evidence of organised planning, defensive structures, and administrative complexity. At its height, it rivaled the great cities of Mesopotamia, standing as a central pillar of the Elamite civilization, a culture that existed for millennia alongside Sumer, Akkad, and later Babylon. Archaeological findings suggest a thriving society with trade connections, craftsmanship, and governance systems that were far more sophisticated than once assumed. The city's significance extended beyond its physical boundaries, embedding itself deeply into the identity of the region. This is perhaps most clearly reflected in its association with Cyrus Jaije, who would later become the founder of the Achaemenid Empire. His adoption of the title King of Anshan was not incidental. It was a deliberate invocation of an ancient and respected seat of power. In that moment, Anshan was not just a place, it was a symbol, a legacy, a source of legitimacy that connected emerging empires to a deeper past. Yet, despite its immense importance, Anshan presents a striking contradiction. For a city that once held such influence, its physical remains are astonishingly subtle. There are no grand palaces rising from the ground, no monumental inscriptions declaring its glory, no vast temples preserved in stone. Instead, what remains are layers of earth, fragments of mud brick and scattered artifacts, traces that hint at greatness but refuse to fully reveal it. Much of the city was constructed using mud brick, a material that, while practical, is vulnerable to erosion over long periods of time. Centuries of wind, seasonal rains, and environmental exposure have gradually reduced its architecture to indistinct forms, blending human construction with natural landscape. However, this explanation only partially accounts for the disappearance. Other ancient cities built with similar materials still retain more recognizable layouts and structures. At Anshan, the absence feels deeper, more complete, as if the city has not only decayed but has been quietly absorbed back into the earth. This sense of incompleteness is further intensified by the limited understanding of the Elamite civilization itself. Unlike Egypt or Mesopotamia, whose histories are preserved through extensive written records and monumental architecture, Elam remains enigmatic. Its language has not been fully deciphered, and many of its inscriptions remain obscure. This lack of clarity creates a barrier between modern researchers and the people who once inhabited Anshan. We can see the outlines of their world, but not the details. We know they built, traded, governed, and worshipped, but how they experienced their lives, what they believed at a deeper level, and how they understood their place in the world remain largely unknown. Anshan, as one of their principal cities, becomes a focal point of this mystery, a place where the gaps in knowledge are most deeply felt. But it is in the story of Anshan's decline that the mystery becomes truly profound. Unlike many ancient cities whose destruction is marked by violence, burned layers of ash, collapsed walls, mass graves, Anshan offers no clear evidence of a catastrophic end. There is no definitive sign of invasion, no widespread destruction that signals a sudden collapse. Instead, the city appears to have faded gradually, its prominence diminishing over time until it was eventually abandoned or transformed beyond recognition. This quiet disappearance is deeply unsettling. It challenges the common narrative of history, where great cities fall through dramatic events, wars, conquests, or natural disasters. Anshan does not follow this pattern. Its decline is subtle, almost invisible, leaving behind a silence that is far more difficult to interpret. One possible explanation lies in environmental change. The region surrounding Anshan may have experienced shifts in climate that affected its agricultural base. Even slight changes in rainfall patterns or water availability could have had significant consequences for a large urban population. Crops may have failed more frequently, water sources may have become unreliable, and the delicate balance that sustained the city could have been disrupted. Over time, these pressures might have led to gradual depopulation, as people moved elsewhere in search of more stable conditions. However, environmental factors alone rarely tell the full story. Cities often adapt, innovate, and endure in the face of such challenges. Another possibility is political transformation. As new powers emerged in the region, the importance of Anshan may have declined. The rise of the Persian Empire, led by Cyrus Jai, marked a significant shift in the political landscape. While Cyrus embraced the title of King of Anshan, the administrative and political centres of his empire were established elsewhere, in cities like Pasargadae and later Persepolis. This suggests that Anshan, while symbolically important, may have lost its practical relevance. Power had moved, and with it, resources, population, and influence. In such a scenario, Anshan would not have been destroyed. It would have been left behind, gradually fading as attention shifted to new centres of authority. There is also the possibility of cultural absorption. Rather than experiencing a clear end, Anshan may have been integrated into the expanding Persian world. Its people, traditions, and institutions could have been absorbed into a larger imperial system, losing their distinct identity over time. This type of transformation is difficult to detect archaeologically. It does not leave behind dramatic evidence. Instead, it manifests as a gradual blending, where one culture dissolves into another. In this sense, Anshan may not have truly disappeared. It may still exist, hidden within the foundations of later civilizations, its legacy continuing in ways that are not immediately visible. And yet, even when these theories are considered together, the mystery remains unresolved. There is no single explanation that fully accounts for the disappearance of such a significant city. The lack of definitive evidence leaves room for speculation, and it is within this uncertainty that Anshan becomes truly fascinating. It is not just a site of ruins, it is a question, an absence that invites inquiry. It forces us to confront the possibility that not all historical events are clearly recorded or easily understood. Today, much of Anshan remains buried. Large portions of the site have yet to be excavated, lying beneath layers of earth that have accumulated over thousands of years. Each new excavation has the potential to reveal critical information, inscriptions that could clarify the Elamite language, architectural remains that could redefine our understanding of the city's layout, artifacts that could illuminate daily life. Until these discoveries are made, Anshan will continue to exist in a state of partial revelation, offering glimpses of its past while withholding its full story. In the end, Anshan stands as a powerful reminder of the fragility of even the greatest civilizations. It shows that a city can be vast, influential, and central to history, and still vanish without a clear trace. Its story is not one of dramatic collapse, but of gradual fading, of quiet transformation, of time erasing what once seemed permanent. And perhaps that is the most unsettling mystery of all. Not that Anshan was destroyed, but that it simply disappeared, leaving behind only silence and the enduring question of how something so important could be lost so completely. What do you think really happened to Anshan? Was it abandoned slowly, or is there still a hidden event we have yet to uncover? Share your thoughts in the comments below. On a remote stretch of land on the island of Hoi, surrounded by windswept moorland and an almost haunting silence, stands one of the most enigmatic prehistoric monuments in Europe, the Dwarfy Stane. At first glance, it appears to be nothing more than a massive, solitary boulder resting in isolation. But this is no ordinary stone. Carved directly into its solid body is a carefully designed chamber, an artificial space created not by assembling materials, but by removing them. It is, in essence, a tomb sculpted from a single monolithic rock, and that alone sets it apart from nearly every other Neolithic structure known to archaeology. The Dwarfy Stane measures roughly 8 meters in length and several meters in height, composed of old red sandstone that has endured the harsh climate of Orkney for thousands of years. Unlike chambered cairns such as Meroe, which were constructed by stacking and arranging multiple stones into intricate formations, the Dwarfy Stane represents an entirely different approach. Here, prehistoric builders chose to work inward, carving out a passage and interior chambers from a single, immovable mass. Inside, a short entrance corridor leads to two small cells, likely intended as burial spaces. The layout is simple, yet deliberate, suggesting planning, precision, and a clear conceptual design. But what truly elevates the mystery of the Dwarfy Stane is not just its form, but its age. Archaeologists generally date the monument to around 3000 BCE, placing it firmly within the Neolithic period. This was a time long before the widespread use of metal tools in Northern Europe. Communities relied on implements made from stone, bone, and wood. Materials that, while effective for many tasks, seem almost absurdly inadequate when faced with the challenge of carving into a massive block of solid sandstone. And yet, somehow this was achieved. This is where the monument begins to challenge not only our assumptions about prehistoric capabilities, but also our understanding of technological development. To hollow out such a structure would have required an extraordinary amount of labour, patience, and technical knowledge. Even with modern tools, carving a clean, stable chamber into a single rock of this size is no trivial task. Without metal chisels or advanced cutting techniques, the Neolithic builders would have had to rely on repeated impact, abrasion, and possibly controlled heating and cooling of the stone to induce fractures. Each strike would have removed only a small amount of material. Each surface would have required refinement. The process could have taken months, if not years. And yet, the interior of the Dwarfy Stane is not crude. It is not chaotic. The walls are relatively smooth, the spaces clearly defined. The proportions are intentional. This was not random excavation. It was execution of a plan. That raises a fundamental question. How did these people conceive of such a project, and how did they maintain the precision needed to complete it? When we compare the Dwarfy Stane to other Neolithic sites in Orkney, such as Skara Brae, we see evidence of remarkable ingenuity. Stone-built houses, drainage systems, organised settlements. But even within this context of innovation, the Dwarfy Stane feels different. It is not part of a village. It is not integrated into a larger complex. It stands alone, both physically and conceptually. Its construction method does not align with the dominant architectural practices of the region. It feels like an outlier, an experiment, or perhaps the expression of a unique cultural or spiritual idea. Some researchers have pointed to similarities between the Dwarfy Stane and rock-cut tombs found in parts of the Mediterranean, including regions like Sicily and Malta. In those areas, ancient cultures also carved burial spaces directly into rock. Could this suggest a form of long-distance cultural transmission? Did ideas travel farther than we once believed, carried by early seafarers across vast stretches of ocean? Or is this a case of convergent development, where different societies independently arrived at similar solutions to similar problems? The chronological implications are profound. If the Dwarfy Stane does reflect influence from distant cultures, it would imply a level of connectivity in the Neolithic world that challenges traditional narratives of isolated development. On the other hand, if it was created entirely independently, it demonstrates that the people of Orkney possessed not only the technical ability, but also the conceptual imagination to undertake such an unusual and demanding project on their own. Equally intriguing is the presence of a large stone slab that appears to have functioned as a door. Positioned near the entrance, this slab could have been used to seal the chamber, closing off the interior space. The idea of a movable stone door suggests an understanding of enclosure, protection, and perhaps ritual significance. This was not merely a hollowed rock. It was a constructed environment with boundaries, with a defined interior and exterior. It may have served as a tomb for a single individual of importance, or perhaps as a symbolic space tied to beliefs about death, transition, or the afterlife. Over time, the Dwarfy Stane has also accumulated layers of mythology. Local folklore speaks of dwarfs or giants, of supernatural beings inhabiting or creating the stone. These stories, while not historical evidence, reveal something important. Even centuries ago, people recognized that this monument did not fit easily into their understanding of the world. It inspired imagination because it defied explanation. And perhaps that is the most enduring aspect of the Dwarfy Stane. It exists at the intersection of simplicity and complexity. It is in one sense just a carved rock, but in another, it is a testament to human determination, creativity, and the desire to shape the environment in meaningful ways. Its age places it among the earliest known examples of such ambition. Its construction challenges our assumptions about what was possible with limited tools, and its isolation only deepens the sense that it was created for a purpose that we may never fully understand. More than 5,000 years have passed since its creation, yet the Dwarfy Stane continues to pose the same quiet, persistent question. How? How did a society without metal, without machines, without written records conceive of and complete such a work? Was it the result of slow, methodical effort over generations, a single visionary project carried out with relentless focus? Or does it hint at knowledge, practical, observational, or even experimental, that has since been lost to time? In the end, the Dwarfy Stane does not offer answers. It offers a challenge. It invites us to reconsider the capabilities of our ancestors, to question the linear narratives of progress we often take for granted, and to acknowledge that even in the distant past, humans were capable of feats that still inspire wonder today. Amid the valley surrounded by the ancient marshes of Campeche, the 5-story palace, the Edzna 5-story palace, rises as a monumental testament to the complexity and mystery of the Maya civilization. This structure, located within the Edzna archaeological site, has long astonished archaeologists not only because of its unique form and rare multi-level architecture, but also due to layers of advanced knowledge embedded into every stone block, every staircase, and every intentionally designed space. From afar, the palace appears like a hybrid between a pyramid and a multi-tiered royal residence. But upon closer observation, one realizes it surpasses all conventional Maya architectural models. It is not perfectly symmetrical, not strictly repetitive, and seems to reflect a design philosophy that modern humanity still fails to fully comprehend. The upper tiers are stacked with deliberate precision, creating a structure that is simultaneously ceremonial, authoritative, and observatory in nature, closely linked with the movement of the sun and celestial phenomena. This multi-layered identity has made the Edzna 5-story palace an unsolved mystery throughout the centuries. Do you believe the Maya possessed technical knowledge far beyond what we know today? In your opinion, what could have enabled them to build such a monumental and precise structure? Share your thoughts in the comments below. Beneath the structure, archaeologists discovered drainage systems so sophisticated that one might assume this was a city from a much later historical era. Underground canals, reservoir, drainage routes, wells, and waterproof foundation layers reveal that Edzna was one of the most hydraulically advanced Maya centers. The inhabitants clearly understood their unstable environment well, and the placement of the 5-story palace at the heart of all these systems was no coincidence. It was protected from water while simultaneously functioning as a natural measuring device for determining seasons, weather cycles, and ceremonial timing. For this reason, no one truly knows whether the building was a palace, a temple, an astronomical observatory, or a combination of all three. Its interior rooms also offer no definitive answers. Some chambers have small doors, some have mysterious entrances, and some have no openings at all. These sealed rooms have sparked endless debate among researchers. Were they ritual storage rooms, prison cells, private ceremonial chambers, or simply older spaces swallowed by later construction phases? No hypothesis fully captures the strangeness of these rooms, and the silence within them only deepens the mystery of the palace. Another striking aspect is the mixture of several Maya architectural traditions within one single structure. The 5-story palace embodies Puk characteristics with its straight, smooth stone facades, Peten influence with its steep pyramid-like tiers, and Chene style expressed in decorated doorways and geometric motifs. This unusual blend has led scholars to believe that Edzna must have been far more than a regional settlement. It was likely a significant cultural crossroads where builders and artisans from various Maya regions converged. The architects here clearly possessed knowledge extending beyond local boundaries, applying it to create a structure unlike anything else in the Maya world. It stands as an architectural manifesto, a declaration of power, and perhaps also a multifunctional structure meant to endure for centuries, even after its inhabitants abandoned the city. Then came the most perplexing event. Around the year 1500, the population of Edzna vanished. There were no signs of war, no large-scale destruction, and no clear evidence of societal collapse. The city was left nearly intact, as if its people departed in complete silence. This peculiar abandonment further elevates the 5-story palace as a symbol of mystery, a massive structure left behind without guardians or explanations. Archaeologists have proposed numerous theories: environmental change, water scarcity, disease, ritual instability, political restructuring, yet none fully aligns with the available evidence. Edzna seems to have fallen into a historical void, and its 5-story palace now stands as a remnant of a world we understand only faintly. However, the greatest mystery, and the most strongly emphasized point, lies in the astonishing construction precision that far exceeded the tools available to the Maya at that time. This is what makes the 5-story palace nearly confrontational to modern engineering. The Maya of Edzna had no hard metals to finely cut stone, no wheels, no beasts of burden, no advanced pulley systems, and no cement-like mortar. Yet they erected a multi-tiered structure with stone blocks cut in perfectly straight lines, fitted so tightly that some joints are said to be no wider than a strand of hair. Walls several meters high remain perfectly upright after millennia, showing no signs of tilting or drift, something many modern buildings cannot achieve without reinforced steel. Long, steep staircases retain sharp geometric edges, revealing sophisticated soil compaction and foundational engineering far beyond what simple stone tools should permit. The upper tiers, which required even more demanding load management, were constructed with astonishing accuracy, prompting archaeologists to ask, how did they lift such massive stones without machinery? Multi-leveled scaffolds? Lever systems? Or perhaps an entirely lost technique never recorded in surviving archaeology? Modern experiments attempting to replicate Maya building methods consistently fail to achieve the same level of flatness, tightness, and structural balance seen in the palace. Some scholars propose that the Maya possessed highly advanced surveying knowledge using sunlight, shadow, or astronomical principles to determine perfect alignment. Others believed that their stone cutting and fitting techniques were far more advanced than what archaeological remains currently reveal, implying that much of their knowledge disappeared when Edzna was abandoned. The truth is unmistakable. This level of precision cannot be explained solely through manpower and primitive stone tools. It suggests extraordinary labor organization, sophisticated engineering management, and a lost architectural tradition. Thus, the phrase construction precision beyond the tools of the time is not merely an archaeological note. It is the very heart of the Edzna mystery, the single greatest reason the palace persists as an intellectual challenge. Yet the palace's mystery does not reside only in its stones, but also in the silence of history itself. The abandoned city, the vanished knowledge, the sealed chambers, the solar-aligned doorways with no worshippers left to observe them, all contribute to the impression that this was a structure built for purposes far beyond daily life. No, it feels like a sacred marker, a cosmic instrument, a declaration of authority, a bridge between the human world and the celestial one, or even an abstract map of Maya cosmology. When its people departed, the palace remained, a quiet witness to the disappearance of knowledge. Today, as one stands before the Edzna 5-story palace, one does not merely see an architectural structure. One confronts a profound gap in humanity's understanding. Its advanced precision does more than astonish. It compels us to ask, did the ancient Maya achieve a level of engineering that modern history has never properly acknowledged? Did their highly refined knowledge vanish with the collapse of Edzna, leaving behind only silent stones, yet stones too perfect to ignore? And more importantly, if a civilization without hard metals, wheels, or pulleys could construct such a masterpiece, how many other secrets of theirs remain undiscovered? Beneath the dry, sun-scorched landscape of Sindh, Pakistan, the site of Kot Diji Fort preserves a story that unfolds not across pages, but across layers of earth. At first glance, the visible fortification appears to belong to a much later historical period, a stronghold perched strategically above the plains. Yet what lies beneath it is far more profound. Excavations have revealed a deeply stratified settlement, where each layer represents a different chapter in human development, stretching back to the early Harappan phase, long before the rise of the great cities of the Indus Valley civilization. These fortification layers are not simply remnants of walls. They are physical evidence of adaptation, resilience, and a level of engineering intelligence that challenges our assumptions about early societies. What makes Kot Diji especially compelling is the continuity of occupation and the repeated rebuilding of its defensive systems. The earliest fortifications, constructed primarily from mud bricks, demonstrate a clear understanding of both materials and environment. Mud brick, often dismissed as primitive, was in fact a highly effective building medium when used correctly. It provided insulation against extreme temperatures and could be produced locally with minimal resources. But at Kot Diji, the use of mud brick goes beyond practicality. The bricks appear to follow consistent proportions, suggesting a standardized system of production. This level of uniformity implies planning, coordination, and possibly even early forms of regulation within the community. As the settlement evolved, so too did its fortifications, and later layers reveal thicker walls, improved structural reinforcement, and more deliberate placement along the natural contours of the terrain. Rather than imposing rigid geometric designs, the builders adapted their architecture to the landscape, maximizing defensive advantage while minimizing construction effort. This indicates a sophisticated understanding of topography, long before formal engineering disciplines existed. In some sections, archaeologists have identified multiple rebuilding phases, where older walls were either reinforced or entirely replaced. These transitions are not random. They reflect a continuous process of evaluation and improvement, as if each generation learned from the successes and failures of the previous one. One of the most intriguing aspects of these layers is the evidence of destruction. These burnt strata, unevenly fired bricks, and collapsed structures point to catastrophic events that disrupted the settlement. Whether these were caused by conflict, accidental fires, or environmental stress remains uncertain. However, what stands out is not the destruction itself, but the response to it. Each time the fortifications were damaged, they were rebuilt, often stronger and more refined than before. This pattern suggests a community that was not only resilient, but also capable of technological progression through experience. The fortifications of Kot Diji are therefore not static constructions. They're dynamic records of learning and adaptation. This brings us to the most remarkable and enigmatic aspect of the site, its construction technology. At first glance, there's nothing extraordinary about mud bricks, simple walls, decadent to basic tools. There is no evidence of advanced metallurgy, no machinery, no written engineering manuals, yet the results speak for themselves. The fortification system is coherent, durable, and strategically effective. The walls are thick enough to provide defense, yet not wastefully so. The layout separates elevated citadel areas from lower residential zones, creating a hierarchical spatial organization that mirrors later urban planning seen in cities like Mohenjo-daro and Harappa. Such planning implies not only technical skill, but also social coordination and governance. How did a society without what we consider advanced technology achieve this level of architectural competence? The answer may lie in a different definition of technology itself. At Kot Diji, technology was not based on complex machines, but on accumulated knowledge of materials, climate, and structural behavior. The builders understood how mud behaves when mixed, shaped, dried, and exposed to the elements. They knew how to align walls to reduce erosion, how to distribute weight to prevent collapse, and how to repair damage efficiently. These are principles that modern engineering still relies on, albeit expressed through more sophisticated tools and calculations. In this sense, the technology of Kot Diji was not primitive, it was optimized for its context. Another striking feature is the apparent efficiency of construction. The fortifications do not show signs of excessive labor or over-engineering. Instead, they reflect a balance between effort and outcome. This suggests that the community had developed methods to organize labor effectively, then possibly through communal systems or early administrative structures. The standardization of bricks alone would have required coordination across production and construction processes. Such organization hints at a level of societal complexity that is often underestimated in pre-urban cultures. The absence of advanced tools also raises important questions. If these structures were built without metal reinforcements or mechanized assistance, then the precision achieved must have relied heavily on human skill. This implies the existence of specialized craftsmen, individuals who possessed detailed knowledge of construction techniques and passed it down through generations. The fortification layers, therefore, are not just physical structures, they're embodiments of human expertise preserved in clay and earth. Perhaps the greatest mystery is not how these fortifications were built, but how such knowledge emerged in the first place. Was it the result of gradual experimentation over centuries? Did it develop independently, or was it influenced by interactions with other early cultures? The continuity observed at Kot Diji suggests an internal evolution, a community refining its practices over time. Yet the similarities with later Harappan cities raise the possibility that this site played a foundational role in the development of one of the world's earliest urban civilizations. In many ways, Kot Diji represents a transitional moment, a bridge between simple rural settlements and fully developed urban centers. Its fortification layers capture this transformation in remarkable detail. They show a community learning to defend itself, thus to organize space and to build with intention. They reveal that even in the absence of what we define as advanced technology, early humans were capable of achieving solutions that were both practical and enduring. As we look at these ancient walls, it becomes clear that the concept of technological advancement is not linear. The builders of Kot Diji did not need steel, concrete, or machines to create effective fortifications. What they had was something equally powerful, a deep understanding of their environment and the ability to apply that knowledge systematically. This is what makes the site so compelling. It challenges modern assumptions and forces us to reconsider what it means to be technologically advanced. Today, much of Kot Diji remains buried, its deeper layers still hidden beneath centuries of sediment, and each unexcavated section holds the potential to reshape our understanding of early human development. The fortification layers we have uncovered are only fragments of a much larger story. A story of innovation without industry, of engineering without machines, and of a society that, despite its apparent simplicity, achieved a level of sophistication that continues to inspire and perplex us. Do you think the builders of Kot Diji developed their knowledge independently, or inherited it from an even older, unknown civilization? Share your thoughts in the comments below. The Castelluccio rock necropolis in Sicily has always been regarded as one of the most mysterious burial complexes of the Mediterranean Bronze Age, not only because of its antiquity, but also due to the meticulous craftsmanship of its construction, which continues to astonish modern researchers. Upon first approaching this remote area, one is immediately struck by its rugged location on steep rocky slopes, a place seemingly unsuitable for any large-scale architectural activity. Yet it was precisely in this hard-to-reach terrain that an ancient culture, known today as the Castelluccio culture, created a necropolis featuring dozens of finely excavated rock-cut tombs, cleverly arranged and bearing artistic, ritualistic, and technical elements far beyond what one might expect for their time. What makes Castelluccio remarkable is that everything left behind, from the tomb entrances and passageways to the dome chambers and deeply carved stone motifs, reflects a level of social organization, aesthetics, and technological capability surpassing what is typically associated with the 18th to 15th centuries BCE. However, the greatest mystery, the center of all debate, lies in the trolley-style tomb structures, with their stone domes built entirely through a dry stone stacking technique, without mortar, yet remaining solid after more than 3 millennia. At Castelluccio, the presence of tholos-type tombs, circular, domed structures more commonly associated with advanced civilizations, forces archaeologists to ask, how could the ancient people here, believed to possess only rudimentary bronze tools, cut, shape, and assemble stone with such precision? The truly structures in this necropolis consist of layers of stone stacked in concentric rings, each tier slightly narrowing inward to form a corbelled vault. Remarkably, the stones were fitted so precisely that almost no gaps remain, and the entire dome stands firm through internal force distribution alone, requiring no binding material. This technique only reappears at comparable sophistication thousands of years later, and even today it is difficult to replicate with exactness. These truly tombs not only remain intact but have also withstood the forces of time, climate, and erosion, a clear testament to the Castelluccio people's mastery over stone far exceeding what official historical narratives have typically acknowledged. Inside the rock-cut tombs, archaeologists have found numerous grave goods revealing the complexity of this ancient society. Distinctive pottery, small tools made of bronze and stone, bracelets, and small figurines demonstrate refined craftsmanship and elaborate funerary rituals. Even more intriguing, some vessels and decorative motifs show puzzling similarities to those from distant cultures such as Anatolia and the Balkans, despite the lack of clear evidence for long-distance trade during this period. This raises questions about the extent of Mediterranean interaction, or the possibility of a deeper yet unexplained cultural connection that scholars have not fully understood. The tomb entrances of the necropolis reveal another layer of mystery, as many are adorned with double spirals or concentric circles, symbols repeatedly seen in various ancient civilizations and often connected to cycles of life-death rebirth, solar worship, or cosmic motion. Yet no written record from the Castelluccio people survives to explain their meaning. These could represent ritual symbols, a religious coding system, or simply artistic decoration. But their consistent and deliberate use suggests they played an important role in the worldview of this ancient community. The necropolis's location is equally perplexing. The Castelluccio people chose to build tombs on steep cliffs where transporting bodies, large stones and construction materials would have been incredibly difficult. Some researchers theorize that they sought to place the dead closer to the sky, or in positions offering significant views related to astronomical events. Others believe the area may have held sacred status long before the necropolis was created, with the burial complex expanding from an earlier spiritual tradition. However, no definitive explanation has been identified. Adding to the enigma is the sudden disappearance of the Castelluccio culture. After several centuries of existence, they seem to vanish from the archaeological record without evidence of warfare, epidemic, or major natural disaster. Some scholars propose assimilation into incoming populations. Others suggest climate change forced migration. More radical interpretations point to a cultural collapse yet to be uncovered. The absence of transitional evidence makes the entire narrative increasingly puzzling, and despite the many mysteries surrounding Castelluccio, the most debated element remains the dry stone corbelling technique that formed the truly styled tombs. These stone domes are not only physical proof of advanced construction ability beyond expectations for the Bronze Age, they also indicate a deep understanding of gravity, force distribution, and stone behavior. Such knowledge typically appears only in highly developed civilizations, passed down through generations of skilled builders. Yet the Castelluccio community, likely small in population, and leaving behind few architectural traces outside the necropolis, achieved what many larger ancient societies could not. This leads experts to ask, did they develop this technique independently, or inherit it from an even older culture? Yeah, could there have been a long-lost network of shared knowledge across the Mediterranean? Or does this reveal that ancient technical sophistication was far more complex than we currently assume? More than 3,000 years have passed, yet the Castelluccio rock necropolis still stands like a stone book never completely opened. Its domed tombs, spiral carvings, remote cliffside location, and abrupt cultural disappearance collectively form a mystery without resolution. But above all, the truly structures and their extraordinary dry stone craftsmanship make Castelluccio one of the strongest reminders that the past may be more complex than we imagine, and that what ancient people left behind often surpasses the boundaries imposed by conventional historical models. In your opinion, what is the most plausible explanation for the extraordinary dry stone construction technique and the mysterious disappearance of the Castelluccio culture? Share your thoughts in the comments below. The Nippur Temple Library, located within the Enlil Temple complex of the Sumerians in Mesopotamia, has long been considered not only an ancient archive, but one of the earliest centers of knowledge humanity has ever known. What makes this place remarkable is not merely its millennia-long age or the enormous number of clay tablets discovered, but the content itself. Records foundational to Sumerian religion, astronomy, mathematics, law, literature, and philosophy. What appeared before archaeologists was not just fragments of cuneiform inscribed clay, but a complete ecosystem of knowledge organized with clear intention. It seems that from a very early period, the Sumerians already understood the value of structuring and preserving information in the form of a library. What do you think enabled the Sumerians to achieve such astonishingly precise astronomical and mathematical knowledge? Share your thoughts in the comments below. Even more astonishing is that Nippur, considered the most sacred center of Sumer, did not only contain ritual or mythological texts, but also a vast amount of scientific material demonstrating intellectual capabilities far beyond what many modern researchers once imagined. When excavation teams uncovered clay tablets buried deep beneath the collapsed temple floor, after centuries of warfare and harsh climate, the surprising fact was that most of them remained intact, even though they had been compressed under geological layers. Archaeologists believe that the Sumerian priests deliberately designed a preservation strategy. Each clay tablet was dried or fired to an ideal durability level, arranged in sets, marked with classification symbols, and stored in spaces intended to minimize environmental deterioration. This reveals a forward-thinking mindset, remarkably similar to the knowledge preservation principles found in modern libraries. A deeper look into the Nippur library reveals extremely early mythological texts, including some of the oldest known versions of the Epic of Gilgamesh, stories of a great flood, divine conflicts, the origins of humanity, and eras long before recorded history, and the uncanny resemblance between these stories and later myths across many civilizations makes researchers question whether Nippur might have been the storage site of the original archetypes of humanity's mythological traditions. Yet even these remarkable discoveries are still not the most mysterious aspect of the library. What makes Nippur truly extraordinary, and the subject of decades of debate, is the presence of astronomical and mathematical tablets, whose accuracy far exceeds what would be expected for their era. Among the thousands of tablets uncovered, scholars identified an abundance of records documenting the movements of the sun, moon, major stars, tidal cycles, religious calendar dates based on astronomical observations, and complex computational tables related to positional mathematics. Many tablets demonstrate calculation abilities that, from a modern viewpoint, seem impossible for a civilization more than 4,000 years old. One striking example is the positional number system used by the Sumerians, the foundation of the base 60 system that underlies timekeeping, celestial cycles, and angular measurement. Even more astonishing, some Nippur tablets describe the lunar cycle with an error margin so small that it nearly matches modern scientific measurements. Furthermore, predictions of lunar eclipses, solar eclipses, and planetary motion also appear, raising the question, how could the Sumerians, without telescopes or optical instruments, observe the sky with such precision? Some scholars attribute this achievement to continuous observation across many generations, recording data for hundreds of years and deducing patterns through mathematics. Yet some tablets indicate a level of predictive accuracy far beyond what naked eye observation alone could produce. For example, certain tablets document the Saros cycle, a roughly 18-year period used to predict eclipses, a form of knowledge typically associated with much later and more advanced astronomical traditions. The existence of such records at Nippur has led many to suspect that the Sumerians inherited an older body of knowledge, perhaps transmitted from an unknown culture predating them, possibly even from a period untouched by archaeology. Another notable feature is the systematic nature of these writings. The astronomical texts of Nippur are not isolated records, but part of an integrated knowledge framework linked to mathematics, calendrical science, agriculture, and religion. The Sumerians believed that heaven and earth operated according to a cosmic order, and understanding that order was the duty of the priests, the only group permitted access to the library. This explains why many of the astronomical texts resemble teaching materials, divided into sections containing comparison tables and offering marginal notes meant to help learners understand. This textbook-like structure suggests that the priestly school at Nippur functioned much like an ancient academy. Moreover, some astronomical mathematical tablets feature highly unusual formats, repeated geometric symbols, abstract formula-like structures, and patterns unlike typical Sumerian writing. Some scholars speculate these were encoded documents reserved for the highest-ranking priests. Others argue they may be remnants of an even older intellectual tradition, perhaps from before the rise of Sumerian city-states. Such discoveries only deepen the mystery, as many of these texts remain undeciphered. When comparing the precision of Nippur's astronomical tablets with modern scientific knowledge, experts realize something profound. The Sumerians did not merely record events, they analyzed and modeled them. Some tablets show awareness of Earth's axial tilt, seasonal cycles, the solar year's length, and discrepancies between lunar and solar time. Such understanding requires not only observation, but an advanced scientific mindset. This sophistication raises the question: were the Sumerians truly the originators of this knowledge, or simply inheritors? The notion that a relatively young civilization like Sumer could calculate the length of the lunar month to near modern precision seems implausible, and this mystery remains unsolved to this day. Beyond the astronomical mathematical corpus, the Nippur library contained an impressively advanced system for organizing texts. Tablets were marked by category, arranged using classification symbols, and show evidence of standardized copying procedures, indicating the library functioned as a fully developed academic institution. The priests not only recorded knowledge but also edited it, producing canonical versions of texts, a task typically found only in highly advanced scholarly environments. Nippur was not only a center of knowledge but also the most important religious center of Sumer. In their worldview, and it was the place where heaven and earth met and where the destinies of the world were determined. This has led many to believe that the Nippur library may have once held texts accessible only to the highest-ranking priests, knowledge that the broader human population never knew existed. The merging of sacred tradition and scientific precision within one institution creates a unique picture, a civilization living simultaneously in myth and in rigorous cosmic calculation. Looking back at the discoveries, one can say that Nippur is not only the world's oldest known library, but also clear evidence that the Sumerians possessed a scientific mindset far more advanced than previously assumed. The extraordinarily precise astronomical and mathematical tablets remain a major question. How could an ancient civilization calculate and preserve such sophisticated cosmic knowledge? Were they inheriting wisdom from a lost past? Or did their intellectual ability surpass the assumptions imposed upon early civilizations? And it is precisely these mysteries that make the Nippur Temple Library one of the most captivating repositories of human knowledge ever discovered.